Subscribe to the channel so you don't miss out on any of these videos. The Butterfly Nebula. Even the name sounds like something out of a fantasy novel, but it's not fiction. It's a real place in space, thousands of light years away, where a dying star has created one of the most breathtaking, complex, and mysterious sights in the universe. But what if I told you that the beauty we see is actually the result of chaos, destruction, and death on a cosmic scale? The Butterfly Nebula isn't just a pretty picture, it's a story, a scientific puzzle, and a glimpse into the ultimate fate of stars like our own Sun. The question is, how does something so destructive create something so stunning? What forces are at play here? Why does this nebula look like a butterfly with outstretched wings? And what does it tell us about the life cycle of stars? These are the kinds of questions that scientists have been trying to answer for decades. What's fascinating is that the Butterfly Nebula doesn't just give us a snapshot of what happens when a star dies. It reveals secrets about the laws of physics, the behavior of gas and dust, and even the future of our galaxy. So, how do you take the death of a star and turn it into one of the most iconic and awe-inspiring images in space? Let's break it down. When a star like our Sun nears the end of its life, it goes through a series of dramatic changes. It burns through its fuel, mostly hydrogen and helium, until there's nothing left to keep it stable. Without that balance between gravity pulling inward and the pressure from nuclear fusion pushing outward, the star begins to collapse. But then, it fights back. It expels its outer layers into space, creating a glowing shell of gas and dust. This is what we call a planetary nebula. Now, here's where things get interesting. The Butterfly Nebula isn't just any planetary nebula, it's one of the most detailed and complex ones we've ever observed. Its wings are made of glowing gas, stretching out for light years. They look symmetrical, almost as if they were designed, but the process that creates them is anything but orderly. Scientists think the symmetry comes from the way the star ejected its material. One possibility is that there's a second star involved, a binary companion. This smaller star might be orbiting the dying star, shaping the way gas and dust flow out. Imagine a garden sprinkler spinning around and creating patterns in the air. It's a bit like that, but on a cosmic scale. The colors you see in images of the Butterfly Nebula aren't random either. They come from different types of gas being energized by the leftover core of the dying star, known as a white dwarf. Hydrogen glows red, oxygen glows green, and nitrogen glows blue. Together, they create this vivid, otherworldly palette. But here's something wild. The Butterfly Nebula isn't just sitting still in space. Its gas and dust are moving, fast. Some parts of the nebula are expanding at speeds of up to 600,000 miles per hour. That's fast enough to circle Earth 24 times in a single hour. And because of this rapid expansion, the nebula won't last forever. In a few thousand years, its gas will disperse into space, leaving behind only the white dwarf at its center. Now, think about that for a second. The Butterfly Nebula is a fleeting moment in cosmic terms, a brief but spectacular phase in the life cycle of a star. It's like catching a firework just as it explodes, knowing that it's beautiful precisely because it won't last. And yet there's still so much we don't understand. For example, why does the Butterfly Nebula have such an intricate shape? What role do magnetic fields play in sculpting it? And what can it teach us about the fate of our own Sun, which will eventually become a planetary nebula of its own? These questions keep astronomers coming back to the Butterfly Nebula, using tools like the Hubble Space Telescope and other advanced observatories. Each new image reveals more details: shockwaves, filaments of gas, and regions of intense heat and radiation. It's like peeling back the layers of an onion, only to find more complexity underneath. But perhaps the most mind-bending thing about the Butterfly Nebula is this: it's not just an object in space. It's a reminder of how connected we are to the cosmos. The elements that make up the nebula, carbon, oxygen, nitrogen, are the same elements that make up you and me. They were forged in the heart of a star, ejected into space, and eventually became part of new stars, planets, and even life itself. So, the next time you look up at the night sky, remember that you're not just seeing stars. You're seeing stories, stories of creation and destruction, of chaos and beauty, of life and death. And among them is the story of the Butterfly Nebula, a cosmic masterpiece painted by the hand of physics itself. What's truly astonishing about the Butterfly Nebula is the level of detail we've been able to capture. When you look at the images taken by telescopes like Hubble, you see tendrils of gas curling outward, almost like smoke from a candle. But unlike smoke, which is chaotic and unpredictable, the patterns in the Butterfly Nebula are surprisingly organized. This symmetry is one of the biggest mysteries. You'd think that a dying star, essentially an explosion of gas and dust, would create something messy, but instead, we get these nearly perfect wings. How does that happen? Scientists believe the answer lies in the hidden forces at play. Take, for instance, the idea of magnetic fields. Magnetic fields are like invisible threads that can shape the movement of charged particles in space. In the Butterfly Nebula, these fields could be acting like a cosmic sculptor, guiding the gas and dust into those distinct patterns. But here's the catch: we can't directly see these fields. All we see are their effects, like the intricate filaments and arcs of material that make up the nebula. Another factor could be the star's spin. If the dying star was spinning rapidly, or if it had a companion star pulling on it, that spin could create the centrifugal forces needed to fling material outward in a symmetrical way. This is one of the leading theories behind the nebula's shape, but there's still a lot of debate. Speaking of companion stars, let's dive into the binary star hypothesis. The idea here is that the dying star wasn't alone. It had a smaller companion star orbiting close by. As the main star expanded and started shedding its outer layers, the smaller star acted like a gravitational anchor, shaping the way the gas was ejected. It's a bit like stirring a pot of soup. Your spoon creates patterns in the liquid as it moves. Now, here's where it gets even more mind-blowing. Some astronomers think there could be more than 2 stars involved. Imagine a whole system of stars interacting with each other, each one influencing the shape of the nebula in subtle ways. If this is true, the Butterfly Nebula could be the result of a cosmic dance, with multiple stars working together to create its stunning form. But it's not just about the stars themselves. The nebula is also a laboratory for studying the behavior of gas and dust in extreme conditions. The temperatures in some parts of the nebula can reach tens of thousands of degrees, causing atoms to ionize and emit light. This is why we see those vivid colors. Each type of gas glows at a specific wavelength when it's energized. And let's not forget about the speed. The gas in the Butterfly Nebula is moving so fast that it's literally stretching space itself. As the material races outward, it creates shockwaves that heat the surrounding gas, adding even more complexity to the nebula's structure. But here's something that might surprise you. We're still not sure exactly how far away the Butterfly Nebula is. Current estimates place it about 4,000 light-years from Earth, but there's a significant margin of error. This might not seem like a big deal, but the distance is crucial for understanding the nebula's true size and the amount of energy involved in its formation. And speaking of size, let's put this into perspective. The wings of the Butterfly Nebula stretch across more than 3 light-years. That's nearly 18 trillion miles. To give you an idea of just how massive that is, if you were to travel at the speed of light, it would still take you 3 years to cross from one wingtip to the other. Now imagine all of this vast expanse of glowing gas, this intricate dance of physics and gravity, existing in perfect silence. There's no sound in space, no roaring flames or crashing waves. Just the quiet hum of the universe at work. What makes the Butterfly Nebula even more fascinating is how it connects to the bigger picture. It's not just an isolated phenomenon, it's part of a larger story about the life and death of stars. When a star like our Sun dies, it leaves behind a white dwarf, a dense core about the size of Earth but with the mass of the Sun. Over time, this white dwarf will cool and fade, becoming a black dwarf, a cold, dark remnant of what was once a blazing star. But before that happens, the gas and dust expelled by the star will mix with the interstellar medium, the vast sea of gas and dust that fills our galaxy. This material will eventually become part of new stars and planets, continuing the cycle of cosmic recycling that has been going on for billions of years. And here's the kicker: The elements in the Butterfly Nebula, the carbon, oxygen, and nitrogen, are the same elements that make life possible. In a way, the nebula is a preview of our own cosmic legacy. One day, billions of years from now, our Sun will create its own planetary nebula. It won't look exactly like the Butterfly Nebula. Every star's death is unique, but it will serve the same purpose: to spread the building blocks of life across the galaxy. This idea, that something as beautiful as the Butterfly Nebula could come from something as violent as a star's death, is a testament to the universe's ability to create order out of chaos. It's a reminder that even in destruction, there's creation. But why does the Butterfly Nebula look so distinct compared to other planetary nebulae? That's one of the big mysteries scientists are still trying to unravel. After all, planetary nebulae are a common stage in the life cycle of medium-sized stars, yet few of them exhibit the kind of symmetry and detail we see in the Butterfly Nebula. What makes this one so special? One possibility lies in its extreme conditions. The gas within the Butterfly Nebula is not only expanding rapidly but also interacting with the surrounding interstellar medium. This collision creates shockwaves, which in turn compress and heat the gas, causing it to glow even more brightly. The wings of the nebula are essentially giant shockwave structures, sculpted by the interplay between the star's ejected material and its environment. But there's more. Observations suggest that the central star of the Butterfly Nebula might be unusually massive for a star at this stage of its life. Most planetary nebulae are formed by stars with masses similar to the Sun, but the star at the heart of the Butterfly Nebula could have started off much larger. A more massive star would produce more energy during its lifetime, leading to a more dramatic and energetic expulsion of gas during its death. And then there's the question of time. Planetary nebulae are short-lived phenomena, lasting only a few tens of thousands of years before fading away. The Butterfly Nebula represents a fleeting moment in cosmic history, and the details we see now are the result of processes that have been unfolding over millennia. The symmetry and structure of the nebula might be the result of its specific stage in this brief life cycle. Perhaps it's a snapshot of a moment when all the forces at play were perfectly balanced. The more we learn about the Butterfly Nebula, the more questions arise. For example, why do some parts of the nebula appear much brighter than others? Could this be due to differences in the composition of the gas, or is it a result of the way light is interacting with the nebula? These are the kinds of puzzles that keep astronomers coming back to this mesmerizing object. One of the most exciting aspects of studying the Butterfly Nebula is the technology we use to observe it. Instruments like the Hubble Space Telescope have given us an unprecedented view of the nebula's intricate details. With each new image, we're able to see more of the filaments, knots, and shockwaves that make up its structure. But even with our most advanced tools, there's a limit to what we can see. The Butterfly Nebula is so far away, and so complex, that we can only capture part of the picture. For example, much of the nebula's mass is in the form of dust, which absorbs visible light and makes it difficult to see what's happening inside. To get a clearer view, astronomers use infrared telescopes, which can detect the heat emitted by the dust. These observations have revealed even more about the nebula's structure, including hidden features that were invisible in earlier images. And then there's the question of its magnetic field. Magnetic fields are notoriously difficult to study, but they could hold the key to understanding how the Butterfly Nebula got its shape. Some astronomers have suggested that the magnetic field of the central star could be acting like a cosmic sculptor, guiding the flow of gas and dust into its distinctive wings. If this is true, then studying the Butterfly Nebula could help us learn more about how magnetic fields influence the evolution of stars and their surroundings. But the Butterfly Nebula isn't just a scientific curiosity, it's also a source of inspiration. Its beauty has captivated people for centuries, long before we understood what it was. In ancient times, objects like the Butterfly Nebula would have been visible only as faint smudges of light in the night sky. It wasn't until the invention of telescopes that we began to see these objects in greater detail, and even then, it took centuries to understand what we were looking at. Today, the Butterfly Nebula is a reminder of how far we've come in our exploration of the universe. It's also a symbol of how much more there is to discover. Despite all our technological advances, we've only just begun to scratch the surface of what's out there. The Butterfly Nebula is one of thousands of planetary nebulae in our galaxy, and each one has its own story to tell. But what makes the Butterfly Nebula so special isn't just its beauty or its mystery, it's what it represents. It's a glimpse into the future of our own sun and a reminder of the cycles that shape the universe. Stars are born, they live, and they die, but their deaths are not an end, they're a new beginning. The gas and dust expelled by dying stars become the raw materials for new stars, new planets, and ultimately, new life. In a way, the Butterfly Nebula is a bridge between the past and the future. It's a relic of a star that lived billions of years ago, but it's also a preview of what's to come. It's a reminder that the universe is constantly changing, constantly evolving, and that we're all part of that process. So, the next time you see an image of the Butterfly Nebula, take a moment to think about what it represents. It's not just a pretty picture, it's a story of life, death, and rebirth on a scale that's almost impossible to comprehend. It's a testament to the power of science to reveal the hidden wonders of the universe, and it's a reminder of how small we are in the grand scheme of things. And yet, in some ways, it's also a reminder of how connected we are to the cosmos. The elements in the Butterfly Nebula are the same elements that make up our bodies, our planet, and everything we see around us. They're a part of us, just as we're a part of them. The Butterfly Nebula offers a breathtaking example of how interconnected everything in the universe truly is. When you consider its origins, a dying star, expelling its outer layers into the void, you can't help but marvel at the way this violent process lays the groundwork for something new. Every atom of gas and dust in the nebula tells a story billions of years in the making, a story that eventually intersects with us. Let's think about the sheer scale of what we're looking at. The Butterfly Nebula might seem like a beautiful, static image, but it's anything but static. It's a dynamic, ever-changing phenomenon. The gas racing outward isn't just moving fast, it's moving at speeds that can exceed 1,000,000 miles per hour. At those speeds, the material could circle Earth in less than a minute. And yet, even at these immense speeds, the process of forming the nebula is slow by human standards. The symmetrical wings we see today didn't form overnight. They're the result of thousands of years of material being ejected layer by layer, shaped by forces we're only beginning to understand. This gradual unfolding is one of the reasons the Butterfly Nebula feels so timeless. But what's even more remarkable is that this beauty is fleeting on a cosmic scale. Planetary nebulae like the Butterfly Nebula don't last forever. As the gas expands and disperses, it becomes harder to see, fading into the interstellar medium. In another 10,000 to 20,000 years, a blink of an eye in the universe's timeline, the Butterfly Nebula will likely be gone, its once vivid wings dissolved into the vastness of space. This ephemeral nature adds a layer of poignancy to its beauty. It's a reminder that even the most awe-inspiring cosmic phenomena are temporary. But that's not a bad thing. The Butterfly Nebula's eventual dispersal is part of the cycle that fuels the universe's creativity. The gas and dust it leaves behind will one day contribute to the formation of new stars and planets. And this brings us to an even deeper mystery, the star at the heart of it all. What's left behind after such a dramatic event? In the case of the Butterfly Nebula, astronomers believe the central star is now a white dwarf, a dense, Earth-sized remnant of what was once a massive, glowing giant. White dwarfs are fascinating objects in their own right. They're the cores of stars that have exhausted their nuclear fuel, no longer capable of fusion. What makes them extraordinary is their density. Imagine compressing a mass comparable to the Sun's into a sphere the size of Earth. A single teaspoon of material from a white dwarf would weigh tons on Earth. This white dwarf is still incredibly hot, glowing brightly in ultraviolet light. It's this intense radiation that energizes the gas around it, causing the nebula to shine in those vibrant hues we see. Over time, however, the white dwarf will cool and fade, becoming a black dwarf, a dark, inert sphere that no longer emits light. The story doesn't end there though. The elements produced by the star during its lifetime, elements like carbon, oxygen, and nitrogen, are now part of the nebula, ready to be recycled into the next generation of cosmic structures. These elements are the building blocks of life, scattered into space to one day become part of new stars, planets, or even living organisms. The Butterfly Nebula also challenges our understanding of symmetry in space. Its wings are so precise and balanced that they almost seem engineered. Scientists are still debating the mechanisms that could produce such an extraordinary shape. Magnetic fields, binary star interactions, and rapid stellar rotation are all part of the discussion, but none of these theories fully explain the nebula's symmetry. This mystery is one of the reasons astronomers continue to study the Butterfly Nebula. It's not just about understanding this particular object, it's about uncovering the universal principles that govern the formation of planetary nebulae. By studying the Butterfly Nebula in detail, we gain insights into the physics of dying stars, the behavior of gas and dust in extreme conditions, and the role of magnetic fields in shaping the cosmos. The more we learn, the more we realize how much we don't know. For example, why do some planetary nebulae exhibit such striking symmetry while others appear more chaotic? What role do unseen forces, like dark matter or unknown magnetic phenomena, play in shaping these structures? These are the kinds of questions that keep scientists pushing the boundaries of what's possible with current technology. And technology is key. The Butterfly Nebula's incredible detail wouldn't be visible to us without tools like the Hubble Space Telescope, which has been capturing images of the universe since the 1990s. Hubble's high-resolution images allow us to see features that would otherwise be invisible, from the fine tendrils of gas to the sharp edges of the nebula's wings. Future telescopes, like the James Webb Space Telescope, promise to reveal even more. Webb's advanced infrared capabilities will allow us to peer through the dust that obscures parts of the nebula, giving us a clearer picture of its structure and composition. These observations could help us solve some of the lingering mysteries about how planetary nebulae form and evolve. But even as we uncover more answers, the Butterfly Nebula retains its ability to captivate and inspire. It's a reminder of the universe's incredible complexity and beauty, a cosmic masterpiece painted by the forces of physics and chemistry. At its core, the Butterfly Nebula is a story of transformation. It's a story of life and death, of destruction and creation, of endings that give rise to new beginnings. It's a story that connects us to the stars, reminding us that we are made of the same elements, shaped by the same forces, and part of the same universe. The Butterfly Nebula's story doesn't just end with its spectacular visuals and profound implications. It also brings us into the realm of interconnectedness that spans the universe. Let's dive deeper into the profound processes at work here. Processes that tie together the nebula's intricate beauty, its scientific importance, and its philosophical implications. When we examine the colors of the Butterfly Nebula, we're not just looking at random bursts of light. Each color is a clue, a signature of the elements within. The glowing red, for instance, indicates the presence of hydrogen, the most abundant element in the universe and the foundation of star formation. The greens and blues are telltale signs of oxygen and other elements like nitrogen. These elements were forged in the heart of the dying star over billions of years, through nuclear fusion processes that release unimaginable amounts of energy. This is where the Butterfly Nebula becomes a bridge between the micro and the macro, between the life of a single star and the grand narrative of the cosmos. The elements created in this stellar forge are the same elements that make up the Earth, the air we breathe, and even our own bodies. Now consider the forces that shaped the nebula's wings. As the star expelled its outer layers, these gases interacted with the surrounding environment, creating shockwaves that sculpted the material into intricate patterns. These forces aren't random. They follow the laws of physics, shaped by gravitational pulls, magnetic fields, and the sheer energy released during the star's collapse. One of the most captivating aspects of the Butterfly Nebula is its bilateral symmetry. It's as if nature decided to paint a masterpiece with mathematical precision. This symmetry isn't just aesthetically pleasing, it's a puzzle that challenges scientists to think about the forces at play during the star's death. Some researchers suggest that binary star systems could be responsible, with one star influencing the other as they orbit a common center. Binary systems are not uncommon in the universe. In fact, many stars are part of such systems. The interaction between two stars can dramatically alter the way a nebula forms. If the dying star in the Butterfly Nebula had a companion, its gravitational pull could have shaped the outflow of gas, creating the symmetrical wings we see today. But there's still much we don't know. For instance, why do some nebulae exhibit this kind of symmetry while others appear chaotic or irregular? What specific role do magnetic fields play in guiding the gas and dust into such intricate patterns? These questions remain at the forefront of astrophysical research, driving scientists to develop new models and run complex simulations to understand the underlying mechanics. The Butterfly Nebula is also a prime example of how light reveals the universe's secrets. The nebula's glow is caused by ionized gas that has been energized by the intense ultraviolet radiation from the central star. This radiation strips electrons from atoms, creating a plasma that emits light as it cools. The result is a luminous, multicolored display that we can observe from Earth. But the light we see is just the beginning. The Butterfly Nebula emits radiation across the electromagnetic spectrum, from radio waves to X-rays. By studying these different wavelengths, astronomers can piece together a more complete picture of the nebula's composition, temperature, and dynamics. For instance, infrared observations can penetrate the dusty regions of the nebula, revealing structures that are hidden in visible light. This multi-wavelength approach has already led to some fascinating discoveries. For example, astronomers have found evidence of molecules like carbon monoxide within the nebula. These molecules are crucial for the formation of more complex organic compounds, which are the building blocks of life. So, in a sense, the Butterfly Nebula isn't just a relic of a dying star, it's also a laboratory for understanding the conditions that might lead to life elsewhere in the universe. By studying objects like this, we gain insights into how the elements and molecules essential for life are distributed across the cosmos. The nebula's scientific importance doesn't stop there. It also helps us refine our models of stellar evolution. Stars like the one at the center of the Butterfly Nebula represent a specific stage in a star's life cycle, one that is critical for understanding how stars contribute to the chemical enrichment of the universe. The more we learn about planetary nebulae like this one, the better we understand the life cycle of stars and the role they play in shaping galaxies. Each nebula is a piece of a much larger puzzle, one that spans billions of years and countless light-years of space. But beyond the science, the Butterfly Nebula invites us to reflect on our place in the universe. It's a reminder that beauty can emerge from destruction, that endings can give rise to new beginnings. The elements released by the dying star will one day be recycled into new stars, planets, and perhaps even new forms of life. This cyclical nature of the cosmos mirrors the cycles we see in our own lives. Just as the Butterfly Nebula transforms from a dying star into a vibrant, luminous cloud, we too are constantly evolving, shaped by forces we often don't fully understand. The Butterfly Nebula is a testament to the interconnectedness of all things. It's a reminder that we are part of a universe that is vast, complex, and endlessly creative. And while the nebula's beauty may be fleeting, its impact, both on the cosmos and on our understanding of it, will endure for generations to come. As we delve deeper into the Butterfly Nebula's mysteries, it's impossible not to be struck by its sheer scale and the forces at play within it. Stretching over 3 light-years, this nebula is far larger than anything we can truly grasp in human terms. It's a cosmic canvas painted with the remnants of a star's life, yet each stroke of gas and dust holds secrets about the universe's past and its future. The Butterfly Nebula, or NGC 6302, is a perfect example of how the death of a star contributes to the birth of something new. The materials expelled during the star's death, hydrogen, helium, oxygen, and heavier elements, are not lost. Instead, they are redistributed into the interstellar medium, creating the raw materials for future stars, planets, and even potential life. This process, called stellar recycling, is one of the key mechanisms that keeps the universe evolving. The core of the Butterfly Nebula, the white dwarf at its center, is particularly intriguing. This remnant of a star is one of the densest objects in the universe, second only to neutron stars and black holes. It's a sphere of degenerate matter, where electrons are compressed so tightly that quantum mechanics becomes the dominant force. Despite its small size, comparable to Earth, the white dwarf contains nearly the same mass as the Sun, making it an object of immense gravitational pull. What's even more fascinating is the white dwarf's temperature. The central star of the Butterfly Nebula is one of the hottest stars known, with surface temperatures exceeding 200,000 degrees Celsius, 360,000 degrees Fahrenheit. This extreme heat generates ultraviolet radiation that ionizes the surrounding gas, causing the nebula to glow with its characteristic colors. The shapes and patterns of the Butterfly Nebula's wings are another area of active research. The symmetry and sharp edges suggest that powerful forces are sculpting the material. While the exact mechanisms are still under debate, one leading theory involves the presence of a binary star system. If the central star had a companion, their gravitational interaction could have directed the outflow of gas and dust, creating the nebula's distinctive shape. Magnetic fields also play a crucial role. They can channel the flow of ionized gas, creating the intricate patterns we see. However, the exact interplay between magnetic fields, stellar winds, and gravitational forces remains a mystery. Advanced computer simulations and observations from telescopes like the Hubble Space Telescope and the James Webb Space Telescope are helping astronomers explore these complex dynamics. Another layer of intrigue lies in the nebula's chemical composition. Studies have revealed the presence of complex molecules, including hydrocarbons, in the Butterfly Nebula. These molecules are the building blocks of more complex organic compounds, which are essential for life as we know it. Their presence raises fascinating questions about how such molecules form and survive in the harsh conditions of space. The Butterfly Nebula also challenges our understanding of time. The light we see from the nebula today left it over 4,000 years ago, traveling across the vastness of space to reach us. This means we're not seeing the nebula as it is now but as it was thousands of years ago. In essence, studying the Butterfly Nebula is like looking into a time capsule, a snapshot of a moment in the universe's history. This time-lagged view also underscores the ephemeral nature of planetary nebulae. While they may seem eternal in the images we capture, they are, in fact, transient. Over tens of thousands of years, a blink in cosmic terms, the gas and dust will disperse, blending into the interstellar medium. The white dwarf at the center will cool and fade, becoming a black dwarf, an object so cold and dark that it no longer emits light. Yet, even as the Butterfly Nebula fades, its legacy will endure. The elements it releases will seed new regions of space, contributing to the formation of stars and planets. In this way, the Butterfly Nebula is not just an end but a beginning, a reminder of the cyclical nature of the universe. Its beauty and mystery also make it a source of inspiration. Astronomers, artists, and dreamers alike are drawn to the Butterfly Nebula, finding in it a symbol of transformation and resilience. It reminds us that even in death, there is creation, and that the universe's capacity for renewal is boundless. Moreover, the Butterfly Nebula highlights the power of human ingenuity. Without the advanced telescopes and instruments we've developed, we wouldn't be able to witness its stunning details or unravel its secrets. Each image of the nebula is a testament to our ability to explore and understand the cosmos, even from our small corner of the universe. As technology continues to advance, our understanding of the Butterfly Nebula and other celestial phenomena will only deepen. Instruments like the James Webb Space Telescope promise to reveal even more about the nebula's structure, composition, and the forces that shaped it. These discoveries will not only enhance our knowledge of the Butterfly Nebula but also shed light on the broader processes that govern the universe. The Butterfly Nebula is a story of cosmic artistry, scientific discovery, and existential wonder. It invites us to marvel at the universe's beauty, question its mysteries, and reflect on our place within it. And while the nebula itself may one day fade, its impact on our understanding and imagination will endure, reminding us of the infinite possibilities that lie beyond the stars. As we continue to explore the Butterfly Nebula, its intricate patterns and stunning beauty reveal more about the universe than we could have imagined. There's something almost poetic about how this celestial object exists in the vastness of space, a dying star that leaves behind a legacy of light and matter that will endure for millennia. But as mesmerizing as the nebula's wings may be, they're only part of a much larger and more profound story about the life and death of stars. The formation of a planetary nebula like the Butterfly Nebula begins long before the star reaches the end of its life. It all starts with a star that is similar to our Sun, though, in the case of the Butterfly Nebula, the star at its center was likely much larger and more massive. As stars age, they go through stages of expansion and contraction, and as their fuel runs out, they can no longer sustain the nuclear fusion processes that power them. This leads to a dramatic change in the star's core. In stars like the one at the center of the Butterfly Nebula, the core eventually collapses inward under the force of gravity, while the outer layers are expelled into space. This expulsion of gas and dust creates what we call a planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. The name comes from their round shape, which early astronomers thought resembled the appearance of a planet through a telescope. What makes the Butterfly Nebula especially fascinating is the complexity of the gas and dust it expels. Most planetary nebulae are relatively simple and circular, but the Butterfly Nebula displays a distinct and detailed structure, with two wings stretching outward from the central white dwarf star. The nebula's wings are shaped like the outstretched wings of a butterfly, which is where the nebula gets its name. This symmetry and detail are not random. They are shaped by the forces at play in the dying star's final moments. One of the theories behind the unusual shape of the Butterfly Nebula involves the role of magnetic fields. These fields are thought to direct the flow of gas as it is expelled from the dying star. While stars generally expel gas and dust in all directions, the powerful magnetic fields around the central star could channel the expelled material into a more structured, symmetrical form. This interplay between gravity, magnetic fields, and stellar winds is a crucial aspect of understanding how nebulae like the Butterfly Nebula are formed. The question of why some nebulae display such intricate patterns while others do not is a subject of much debate in the field of astrophysics. While magnetic fields seem to be a likely factor, there are still many unknowns. It's possible that the presence of a companion star in a binary system, as previously suggested, could play a role in shaping the nebula. The gravitational interaction between two stars could influence the shape of the gas cloud, pulling it into a more structured form. This could explain the sharp edges and distinct symmetry of the Butterfly Nebula's wings. Another important aspect of the Butterfly Nebula is its age. At over 4,000 light-years away from Earth, we are seeing the nebula as it appeared in the past. Light from the nebula takes thousands of years to reach us, which means that the current state of the nebula is likely very different from what we observe. Over the course of thousands to tens of thousands of years, the gases and dust of the nebula will slowly disperse into space, enriching the surrounding environment with the elements created by the dying star. In this way, the nebula is not just a temporary feature of the cosmos, but rather an important part of the ongoing cycle of matter in the universe. This process of stellar death and rebirth is fundamental to the existence of the elements that make up everything we know. Stars are responsible for forging elements like oxygen, carbon, and nitrogen, the building blocks of life. When a star dies, the elements it created are released into space, where they can eventually be incorporated into new stars, planets, and even life forms. The Butterfly Nebula is a perfect example of this process in action, as the elements expelled by the dying star will go on to contribute to the formation of new stars and planetary systems. As we continue to study the Butterfly Nebula, we gain a deeper understanding of not only the life cycle of stars, but also the larger forces at play in the universe. The nebula serves as a reminder of the immense power and beauty of the cosmos, as well as the interconnectedness of all things. The gas and dust from the nebula will eventually become part of something new, a star, a planet, or even a molecule that could one day be a part of life elsewhere in the universe. In this way, the Butterfly Nebula is not just a symbol of a star's death, but a symbol of life's eternal cycle. The universe is constantly in flux, with stars being born, living, dying, and giving birth to new generations of stars and planets. The elements that make up our bodies, the Earth, and everything we know were once part of the hearts of ancient stars. In this way, the Butterfly Nebula is a reminder of our deep connection to the cosmos, and the cycle of creation and destruction that governs the universe. As we look forward to future discoveries, particularly with the help of new technologies like the James Webb Space Telescope, we are sure to learn even more about the Butterfly Nebula and other celestial wonders like it. These observations will continue to shed light on the processes that shape the universe and deepen our understanding of the fundamental laws of physics that govern all of existence. The Butterfly Nebula's intricate structure, its scientific significance, and its profound beauty continue to captivate the imagination of astronomers and stargazers alike. It is one of the many cosmic wonders that serve as a reminder of both the fragility and resilience of the universe. Its wings may eventually fade into the cosmic dust, but the story of its creation, destruction, and rebirth will live on in the stars and in our understanding of the universe itself. As we continue to observe and analyze the Butterfly Nebula, we begin to realize just how much there is still to uncover. The mystery of this stellar phenomenon continues to challenge astronomers, pushing the boundaries of our knowledge about the evolution of stars and the dynamics of interstellar matter. With every observation, we get a step closer to understanding the true nature of this extraordinary nebula and its place in the cosmic cycle. One aspect of the Butterfly Nebula that remains enigmatic is its central star. The white dwarf at the heart of the nebula is a particularly fascinating object. It represents the final stage in the life of a medium-sized star, such as the Sun, but the processes occurring around it are still not entirely understood. The white dwarf itself is the remnant of the star's core, left behind after the outer layers were blown off in a violent expulsion of gas and dust. However, what remains is a highly dense and extremely hot stellar remnant, with temperatures exceeding 200,000 degrees Celsius, 360,000 degrees Fahrenheit. This extreme heat is key to the nebula's glowing appearance. The ultraviolet radiation emitted by the white dwarf ionizes the surrounding gas, causing it to emit light at specific wavelengths. These emissions give the Butterfly Nebula its characteristic glow, with colors ranging from green to blue and red, depending on the elements involved. The interaction between the central star's radiation and the surrounding gas is a primary reason the nebula appears so vibrant and complex. But the true nature of the white dwarf itself, especially in the context of the Butterfly Nebula, remains a subject of intense investigation. For example, researchers are still working to understand how the star's radiation can sculpt such intricate and asymmetric structures in the surrounding nebula. The fact that the nebula's wings extend so far out into space, some 3 light-years in total, suggests that the forces at play are truly immense, far greater than anything we experience here on Earth. One potential explanation for the nebula's unusual structure comes from the theory of stellar wind shaping. Stellar winds are streams of charged particles emitted by the star. In most planetary nebulae, these winds flow uniformly in all directions, but the Butterfly Nebula's distinct wings imply that the stellar wind is being channeled or directed in specific ways. As already mentioned, magnetic fields could play a significant role in this process, but some researchers suggest that the nebula's formation could be influenced by the interaction of the star's radiation with surrounding interstellar material. These interactions could create the sharp, butterfly-like shape we see today. Another intriguing idea is the potential involvement of a companion star in a binary system. Binary stars, where 2 stars orbit each other, are common in the universe, and the gravitational interaction between the two can cause strange and dramatic effects. In the case of the Butterfly Nebula, a companion star could have contributed to the shaping of the gas cloud, pulling it in one direction or another. This kind of interaction could explain the symmetry and structure we observe in the nebula. However, it's important to recognize that while these theories are compelling, the Butterfly Nebula still holds many secrets. The precise mechanics behind its formation are still a matter of speculation, and much more research is needed to fully understand the forces at work. Telescopes like the Hubble Space Telescope and the upcoming James Webb Space Telescope are helping to shed light on these mysteries, offering higher-resolution images and more detailed spectral data. But even with the most advanced instruments, the complexity of nebulae like the Butterfly Nebula means that many questions remain unanswered. As we look at the Butterfly Nebula, it's impossible not to consider the broader implications of such phenomena. Stars, in their various stages of life, shape the very fabric of the universe. Their birth, life, and death cycle the essential elements of the universe, enriching the interstellar medium with the building blocks of new stars, planets, and even life itself. The Butterfly Nebula is just one example of how stars give back to the cosmos. Its gas and dust will eventually mix with the materials from other dying stars, and in the future, they may contribute to the creation of new stars and even new planetary systems. This process of stellar recycling is a fundamental feature of the universe. Stars are the forges of the elements, and through their lives and deaths, they fuel the ongoing cycle of cosmic evolution. The Butterfly Nebula, as a product of a dying star, serves as a symbol of this process, reminding us that even in death, there is creation. Every element in our bodies, every piece of matter on Earth, was once forged in the heart of a star, and every new star or planet that forms from the debris of dead stars carries the legacy of those ancient suns. In a sense, the Butterfly Nebula is not just a stunning visual spectacle, it's also a lesson in the interconnectedness of all things. It's a reminder that everything in the universe is part of a larger, ongoing process. As we look at the nebula's delicate wings and glowing gas, we're not just seeing the death of a star, we're witnessing the beginning of something new. And in this sense, the Butterfly Nebula embodies the timeless dance of life, death, and rebirth that governs the universe. With each new discovery, the Butterfly Nebula continues to inspire wonder and awe. It is a reminder of how much we still have to learn about the cosmos and how little we truly know. Yet, at the same time, it serves as a testament to human curiosity and ingenuity. Our ability to observe, study, and understand such distant and complex phenomena is a triumph of science and technology, and as our tools and methods continue to improve, so too will our understanding of the universe's many mysteries. Ultimately, the Butterfly Nebula is more than just a beautiful cosmic object. It is a window into the fundamental processes that govern the universe. It represents both the end of one story and the beginning of another. It is a cosmic reminder that in the grand scheme of things, the death of a star is not an end, it is part of a larger cycle of creation and transformation that spans the entire universe. From the dust and gas expelled by dying stars like the one at the center of the Butterfly Nebula, new stars and new worlds will emerge, carrying with them the building blocks for future life and future discoveries. The story of the Butterfly Nebula is a story of renewal, of cosmic recycling, and of the interconnectedness of all things. As we continue to peer deeper into space, the Butterfly Nebula will undoubtedly remain one of the most captivating objects in the night sky. It is not just a reminder of the beauty of the cosmos, but also a powerful symbol of the ongoing processes that shape the universe and everything within it. As we explore deeper into the intricacies of the Butterfly Nebula, it becomes clear that this stellar remnant is far more than a cosmic curiosity. It's a testament to the power of stellar evolution and the unseen forces that govern the universe. The nebula is a stark reminder that the universe is constantly in flux, transforming as stars live, die, and regenerate the very material needed for new stars and planets to form. This process of stellar death, where the outer layers of a star are ejected into space, is part of what is known as a planetary nebula phase. This term might seem a bit misleading, as these nebulae have nothing to do with planets. The name comes from the way these objects appeared in early telescopes, resembling the shape of a planet or disk. However, they are the remnants of medium to low-mass stars that have exhausted their fuel, no longer able to sustain nuclear fusion in their cores. At the heart of the Butterfly Nebula, we find the central white dwarf, which is the exposed core of the star that once illuminated the nebula's gaseous wings. The white dwarf itself is a fascinating object, about the size of Earth but packing a mass similar to that of the Sun. This immense density means that a single teaspoon of white dwarf material could weigh about a ton on Earth. The intense gravity of the white dwarf prevents the outer layers of the star from falling back inward. Instead, the ejected gas and dust spread outward, forming the nebula that surrounds it. One of the most remarkable aspects of the Butterfly Nebula is its apparent symmetry. The nebula's wings stretch outward in a delicate, butterfly-like formation, giving it a striking visual appearance. However, this symmetry might be the result of multiple factors at play, including the star's rotation, magnetic fields, and possibly even the presence of an unseen companion star. Astrophysicists have long speculated about the role that a companion star might play in shaping such a nebula. In many cases, binary star systems, where two stars orbit each other, have been found to significantly influence the evolution of their components. If the central star of the Butterfly Nebula is part of such a system, its companion could have a profound impact on the nebula's structure. The gravitational interaction between the two stars might channel material in particular directions, creating the nebula's distinct shape. This could also explain the presence of various structures, such as jets of gas and intricate filaments of dust, that extend away from the central star. However, while a binary companion is a compelling hypothesis, it is far from the only explanation. Other theories suggest that the star's rotation and its magnetic field could be responsible for the nebula's unique geometry. A rapidly rotating star would create centrifugal forces that could push material outward in specific patterns, leading to the formation of the nebula's wings. Additionally, the magnetic field of the star might interact with the surrounding gas in such a way as to funnel and shape the material. These forces, combined with the stellar winds, streams of charged particles emitted by the dying star, could produce the nebula's distinctive appearance. The exact cause of the butterfly shape remains an open question, and astronomers continue to explore different models to explain the structure of the Butterfly Nebula. This is an area of active research, with new data from instruments like the Hubble Space Telescope offering insights into the fine details of the nebula's structure. The more we learn, the clearer it becomes that the processes involved in shaping a nebula are as complex as the stars themselves. One thing that's certain, however, is the beauty of the Butterfly Nebula. It is one of the most stunning objects in the night sky, offering a window into the end stages of stellar life. The nebula's intricate patterns of gas and dust, glowing with vibrant colors, create a cosmic tapestry that captures the imagination. Each cloud of gas, each thread of dust, tells a story of a star's final moments, a story that is both tragic and beautiful. As we look at the Butterfly Nebula, we are reminded of the transience of stars and the universe itself. A star's life cycle is a process of continuous transformation, birth, life, death, and rebirth. The nebula that surrounds the dying star is not just the end of one chapter, but the beginning of another. The gas and dust expelled by the star will eventually mix with the interstellar medium, providing the raw materials for the next generation of stars. In this way, the death of a star is not a finality but a stepping stone in the ongoing evolution of the cosmos. In fact, the very elements that make up the planets, stars, and even life on Earth were formed in the hearts of ancient stars. These elements were scattered across the galaxy when those stars exploded or shed their outer layers. The Butterfly Nebula is part of that cosmic cycle, adding to the rich tapestry of matter that will one day form new stars and planets. It is a powerful reminder that nothing in the universe is truly lost. Everything is recycled, remade, and transformed. The future of the Butterfly Nebula is also a subject of great interest. As the nebula continues to expand and the central white dwarf cools over billions of years, it will eventually fade from view. However, its legacy will live on. The materials it has expelled into space will contribute to the formation of new stars, planets, and potentially even life. In this sense, the nebula is not just a fleeting spectacle, but a key part of the ongoing process of cosmic evolution. For now, we can continue to observe and study the Butterfly Nebula, marveling at its beauty and complexity. With every new observation, we gain a deeper understanding of the processes that govern the lives of stars and the formation of the structures that surround them. And with each new discovery, we are reminded of the vastness and mystery of the universe, and how much there is still to explore. Ultimately, the Butterfly Nebula is more than just a stunning visual object. It is a symbol of the dynamic and ever-changing nature of the cosmos. It tells a story of stellar death, but also of rebirth. It reminds us that the universe is not static, it is in a constant state of flux, driven by the forces of creation and destruction. The Butterfly Nebula, like so many other objects in the universe, is a reminder that even in death, there is the potential for new life. As we look out at the stars and the nebulae that surround them, we can't help but feel a sense of awe and wonder. The universe is a vast and mysterious place, filled with objects and phenomena that challenge our understanding and spark our imagination. The Butterfly Nebula is just one of many such objects, a reminder that even in the most distant reaches of space, there is beauty, complexity, and mystery waiting to be uncovered. It is a cosmic work of art, a testament to the incredible forces at work in the universe, and a symbol of the endless cycle of life, death, and rebirth that governs the cosmos. The journey through the Butterfly Nebula is far from complete, and as we continue exploring this stellar masterpiece, it becomes evident that every new discovery opens up more questions, urging us to dive deeper into its mysteries. The more we learn about the nebula, the more we uncover about the life cycle of stars and the processes that shape the very fabric of our universe. One of the aspects of the Butterfly Nebula that continues to intrigue scientists is the precise nature of the gas and dust that have been expelled by the dying star. The nebula's gas is primarily composed of hydrogen and helium, the most abundant elements in the universe, but it also contains trace amounts of heavier elements like oxygen, nitrogen, and carbon. These elements were forged in the heart of the star during its lifetime, and when the star sheds its outer layers, they are expelled into space. Over time, these elements will contribute to the formation of new stars, planets, and even life, continuing the cycle of cosmic evolution. The gas in the Butterfly Nebula is not evenly distributed. Instead, it forms complex patterns and structures, such as the wispy filaments that stretch out from the central star. These filaments are the result of the interaction between the star's intense radiation and the surrounding gas. As the star emits ultraviolet light, it ionizes the gas, causing it to glow. The intensity of the light varies across the nebula, creating a stunning array of colors that range from deep red to blue and green. These colors are the result of different elements in the gas emitting light at specific wavelengths. For example, the red hues are primarily caused by the emission of hydrogen, while the blue and green colors are associated with oxygen and nitrogen. These structures are not random. They are shaped by the forces at play within the nebula. The star's powerful winds, combined with the magnetic fields and the star's rotation, create patterns that stretch across the nebula, twisting and curling the gas into intricate shapes. The shape of the Butterfly Nebula is a direct result of these interactions, and scientists are still working to fully understand how all of these forces come together to produce such a beautiful and complex structure. One of the most fascinating features of the Butterfly Nebula is the presence of high-speed jets of gas that extend outward from the central star. These jets are believed to be the result of the star's magnetic field, which funnels gas away from the star's surface and accelerates it to extremely high velocities. These jets are highly collimated, meaning they remain narrow and focused as they travel outward, creating two distinct lobes that resemble the wings of a butterfly. The jets can reach speeds of up to 1,000 kilometers per second, a staggering velocity that causes the gas to travel vast distances across space. The exact mechanism behind the formation of these jets is still not fully understood, but they are thought to be an important part of the process that shapes the nebula. As we delve deeper into the composition of the Butterfly Nebula, we also encounter the faint remnants of the star's original atmosphere. This atmosphere, once composed of the star's outer layers, has been blown away over time by the intense radiation and solar winds. What remains is a cloud of gas and dust that has been sculpted by the forces of the star's death. This material is not just an empty shell. It is rich in information about the star's history and the processes that led to its demise. By studying this material, scientists can gain insights into the star's chemical composition, its age, and the conditions that led to its transformation into a planetary nebula. The study of planetary nebulae like the Butterfly Nebula has profound implications for our understanding of the cosmos. These objects are not just a glimpse into the death throes of a single star, but a window into the future of our own Sunday. Our Sun, like the star that formed the Butterfly Nebula, will eventually exhaust its nuclear fuel and enter the planetary nebula phase. This is a process that will take billions of years, but the final result will be a nebula not unlike the Butterfly Nebula, with a white dwarf at its center. By studying nebulae like this one, scientists can gain valuable insights into the future of our own solar system and the fate of our Sun. But the Butterfly Nebula also raises larger questions about the nature of life and death in the universe. The gas and dust that make up the nebula will eventually be incorporated into other star-forming regions, contributing to the creation of new stars, planets, and possibly even life. This process, known as stellar recycling, is a fundamental part of the cosmic life cycle. It is a reminder that the universe is a dynamic, ever-changing place, where nothing ever truly disappears. Even the death of a star, once thought to be an end, is merely a transition into something new. The nebula's eventual fate is another point of interest for astronomers. Over time, the gas will continue to spread out into space, becoming more diffuse and less visible. The central white dwarf will continue to cool and fade, eventually becoming a faint, dim object in the distant future. However, the nebula's influence will continue long after it has faded from view. The elements it has released into space will form the building blocks for the next generation of stars and planets. In this way, the Butterfly Nebula will continue to play a vital role in the ongoing evolution of the universe, even as it gradually disappears from sight. One of the things that makes the Butterfly Nebula so captivating is the sheer scale of the processes involved. The gas and dust that make up the nebula are spread out across vast distances, and yet the nebula itself is incredibly delicate. The intricate patterns of gas and dust that we see today are the result of billions of years of evolution, a combination of forces that have shaped the nebula into the stunning object we see today. This is a reminder that the universe is full of immense forces that operate on scales far beyond our comprehension. The Butterfly Nebula, in all its beauty and complexity, is a testament to the grandeur of the cosmos and the power of the forces that govern it. The study of the Butterfly Nebula is not just about understanding the end of a single star's life. It is about exploring the larger processes that govern the evolution of stars, galaxies, and the universe as a whole. It is a reminder that every object in the cosmos, no matter how small or distant, is part of a larger story, a story that stretches across time and space. As we continue to study the Butterfly Nebula and other stellar remnants like it, we gain a deeper understanding of our place in the universe and the forces that have shaped our world. The Butterfly Nebula's story is a cosmic tale of life, death, and rebirth, and it serves as a reminder that the universe is always in motion, constantly evolving, transforming, and renewing itself. With each new discovery, we come closer to understanding the mysteries of the cosmos and our own place within it. The Butterfly Nebula, with its intricate patterns and stunning beauty, is a testament to the incredible complexity of the universe and the ever-present forces that shape it. As we continue our exploration of the Butterfly Nebula, one fascinating aspect to consider is the star at the center of it all. The nebula's formation is the result of a dying star that has gone through a process of shedding its outer layers. But what was this star like in its earlier stages, and how did it come to be at the end of its life cycle? The star that formed the Butterfly Nebula was likely a red giant. This type of star is in a phase of its life where it has exhausted the hydrogen fuel in its core, causing the star to expand and cool. Red giants are notorious for their massive size compared to the Sun, sometimes being up to 100 times larger in diameter. As these stars burn through their nuclear fuel, their cores contract, and the outer layers of the star expand and cool. Eventually, the outer layers are ejected into space, leaving behind a dense, hot core that becomes a white dwarf. The white dwarf at the center of the Butterfly Nebula is what remains after the red giant has shed its outer layers. This small, but incredibly dense, remnant of the star is composed primarily of carbon and oxygen. Despite its relatively small size, about the size of Earth, the white dwarf has a mass comparable to that of the Sun. Over time, it will continue to cool and fade, but for now, it provides the intense ultraviolet radiation necessary to ionize the gas and dust in the surrounding nebula, causing it to glow in vibrant colors. This process, known as the planetary nebula phase, is not unique to the Butterfly Nebula. In fact, planetary nebulae are quite common in the universe, especially in the later stages of stellar evolution. They represent the end of a star's life cycle, where it transitions from a red giant to a white dwarf, leaving behind a beautiful and intricate nebula of gas and dust. What makes the Butterfly Nebula unique, however, is its stunning symmetry and the complex patterns of gas and dust that have been formed during the star's final moments. The symmetry of the Butterfly Nebula, with its two distinct lobes of gas and dust, is a result of the complex interactions between the dying star's radiation, magnetic fields, and stellar winds. These forces work together to shape the nebula into its distinctive butterfly-like shape. It is a reminder of the incredible complexity of the universe and how even the most destructive events can lead to the creation of something beautiful. In addition to the star's radiation and magnetic fields, the presence of a companion star in a binary system could also play a role in the nebula's formation. Many planetary nebulae, including the Butterfly Nebula, are thought to have formed in binary or multiple star systems. In these systems, the companion star's gravitational influence can help shape the ejected material and cause it to be expelled in specific patterns. The interaction between the stars in such systems can also cause the nebula to become more asymmetric, as the gravitational pull of the companion star can affect the trajectory of the ejected gas. The formation of planetary nebulae like the Butterfly Nebula is an important process in the recycling of material in the universe. As stars like the one at the center of the nebula shed their outer layers, they contribute essential elements like carbon, oxygen, and nitrogen to the surrounding space. These elements will later be incorporated into the formation of new stars, planets, and even life. The Butterfly Nebula, like all planetary nebulae, is a reminder that the universe is constantly evolving, with the death of one star giving rise to the potential for the creation of new worlds. The gas and dust in the Butterfly Nebula will eventually disperse into the interstellar medium, the vast, empty space between stars. Over millions of years, this material will mix with other gases and dust, forming new regions of star formation. The elements that make up the nebula, hydrogen, helium, carbon, oxygen, and others, are the building blocks of future stars and planets. This process of stellar recycling is one of the fundamental cycles of the universe, ensuring that the elements forged in the hearts of stars continue to play a role in the creation of new celestial bodies. The Butterfly Nebula is not just a beautiful cosmic object, it is also a key piece in the puzzle of stellar evolution. By studying this nebula and others like it, scientists are learning more about the processes that govern the life cycles of stars and the way in which stars contribute to the overall evolution of the universe. The nebula is a testament to the way in which the cosmos is constantly changing, with each star, each nebula, each galaxy playing its part in the ongoing story of the universe. One of the most profound implications of studying nebulae like the Butterfly Nebula is the realization that we are connected to the stars in a very real and fundamental way. The elements that make up our bodies, carbon, oxygen, nitrogen, and others, were forged in the cores of stars just like the one that formed the Butterfly Nebula. In a very real sense, we are made of star stuff. The same processes that give rise to the beauty and complexity of the nebula are the same processes that have shaped the planets, the stars, and even life itself. The nebula's stunning beauty, with its intricate patterns of gas and dust, serves as a reminder of the complexity and wonder of the universe. The Butterfly Nebula is a symbol of the ongoing cycle of life and death in the cosmos, where stars are born, live, die, and give birth to new stars, planets, and perhaps even new forms of life. It is a cosmic dance that has been happening for billions of years and will continue for billions more. The Butterfly Nebula is not just the dying star's final gift to the universe. It is a window into the processes that have shaped the universe as we know it. It is a glimpse into the future of our own sun, which will one day go through a similar process, shedding its outer layers and leaving behind a white dwarf at the center of a planetary nebula. It is a reminder that, in the grand scheme of the cosmos, life and death are part of a larger, ever-changing cycle, one that continues to unfold with every new star that is born, every nebula that forms, and every new discovery that brings us closer to understanding the universe. The Butterfly Nebula's captivating beauty is a product of a process that spans millions of years, but it also tells a story that is much larger than itself. It is a reminder that the universe is full of mysteries, waiting to be uncovered. As we continue to study the nebula and other cosmic phenomena, we gain new insights into the nature of the universe and our place within it. The Butterfly Nebula is just one example of the countless wonders that await us in the vastness of space. As we delve deeper into the Butterfly Nebula and its captivating narrative, we begin to recognize just how much information can be derived from studying a single celestial object. The Butterfly Nebula is not only a testament to the incredible processes occurring within dying stars, but it also offers a deeper look into the relationship between stars, their life cycles, and their profound effects on the universe. The nebula is located approximately 3,800 light-years from Earth, in the constellation of Scorpius. This vast distance underscores just how extraordinary it is that we can observe such detailed and intricate structures so far away. Despite the distance, astronomers are able to study the nebula in stunning detail, thanks to advancements in technology and space-based telescopes like the Hubble Space Telescope, which provided us with the breathtaking images we associate with this nebula. These images reveal a complex and beautiful structure, but they also allow scientists to investigate the very elements that make up the nebula. These elements are not random. They are precisely the materials that were once part of the star before it began its final stages of life. Each element in the Butterfly Nebula, from hydrogen to carbon to oxygen, tells a unique story about the star's evolution. This stellar recycling is essential not just for understanding the nebula but also for understanding the life cycle of galaxies, the formation of new stars, and the origins of life itself. One intriguing aspect of the Butterfly Nebula is its asymmetric structure. While the nebula is often described in terms of its butterfly wings, the pattern is far from uniform. The two lobes of gas and dust, although roughly symmetrical, are slightly offset in their shape and density. This asymmetry could be explained by the star's rotational dynamics, the presence of magnetic fields, or even the interactions with a nearby companion star, as we've previously discussed. These factors could all contribute to the uneven distribution of material, ultimately leading to the formation of the butterfly's wings. In addition to the physical forces at play within the nebula, the chemical composition of the gases and dust within the Butterfly Nebula is another critical area of interest. Studies of the nebula have revealed a wealth of chemical diversity, with a mix of elements including hydrogen, helium, carbon, nitrogen, oxygen, and others. These elements are the building blocks for life, and their presence in the nebula suggests that the material ejected by dying stars plays a vital role in enriching the interstellar medium with the necessary ingredients for new star systems, planets, and perhaps even life. The presence of carbon and oxygen in the Butterfly Nebula is particularly significant. These elements are key components of life as we know it, and they are formed in the cores of stars through nuclear fusion. As a star dies and ejects its outer layers into space, it not only shares its chemical building blocks with the surrounding interstellar medium, but it also helps set the stage for the formation of new stars and planets. This process, known as stellar nucleosynthesis, ensures that the elements that compose the world around us, including our own bodies, were once forged in the hearts of stars. But the Butterfly Nebula's beauty and scientific importance go beyond the chemical and physical properties of its gas and dust. The nebula also provides valuable insight into the dynamics of stellar evolution. Understanding the mechanisms that govern the formation of nebulae like the Butterfly Nebula helps astronomers predict the future of our own Sun and other stars in our galaxy. It also provides a glimpse into the long-term evolution of star systems, galaxies, and the universe as a whole. For example, the study of planetary nebulae like the Butterfly Nebula allows scientists to model the fate of stars that are similar to the Sun. The Sun, too, will eventually enter the red giant phase and undergo a similar process of shedding its outer layers, creating a nebula. This will mark the end of the Sun's life cycle, ultimately leaving behind a white dwarf that will gradually cool over billions of years. By studying nebulae like the Butterfly Nebula, scientists are able to better understand the long-term fate of stars, including the Sun, and the eventual changes that will take place within our solar system. While the fate of our Sun may seem far off, in astronomical terms, it is important to understand that stars like our Sun are not eternal. They undergo predictable stages of development, from their formation in nebulae to their eventual death as white dwarfs. The Butterfly Nebula is a perfect example of how these stages play out on a cosmic scale, and it provides invaluable data that can help astronomers predict the fate of our own star. The life cycle of a star is a remarkable journey, and studying the stages of stellar evolution is one of the most significant ways that astronomers unlock the secrets of the universe. Every star, from its birth in a molecular cloud to its death as a white dwarf, supernova, or black hole, leaves behind a trail of cosmic breadcrumbs. By following this trail, scientists can piece together the history of the universe and gain a deeper understanding of the forces that govern the cosmos. But the Butterfly Nebula isn't just important for understanding the evolution of stars. It also sheds light on the broader processes that shape galaxies, the interstellar medium, and the universe as a whole. The nebula is a perfect example of the way in which stars contribute to the galactic ecosystem, enriching the surrounding space with the elements needed for the formation of new stars and planets. As the gas and dust in the Butterfly Nebula continue to expand into the surrounding interstellar medium, they will mix with other material, eventually becoming part of new molecular clouds. These clouds will then serve as the birthplace for new stars, which will go through their own life cycles and ultimately give birth to new nebulae. This ongoing cycle of star birth, death, and rebirth is what drives the evolution of galaxies, the formation of new planetary systems, and the distribution of the elements that make up the universe. In the grand scale of things, the Butterfly Nebula is just one of countless nebulae scattered across the universe, each telling its own unique story. Yet, despite the vastness of the cosmos, these nebulae are linked together through the shared processes of stellar evolution. The formation of a nebula is part of a larger cosmic cycle, one that transcends individual stars and extends across galaxies and even the entire universe. Through the study of nebulae like the Butterfly Nebula, we are able to gain insights into the fundamental workings of the universe. We learn about the forces that shape stars, the chemical processes that lead to the formation of new worlds, and the long-term evolution of galaxies. The Butterfly Nebula is not just a beautiful object in the sky, it is a symbol of the incredible complexity of the universe and the dynamic interplay of life, death, and rebirth that defines the cosmos. The fascinating beauty of the Butterfly Nebula and its underlying science reminds us of just how much there is to discover in the universe. Whether it's understanding the forces that shape stars, the chemical processes that create life, or the grand-scale workings of galaxies, the Butterfly Nebula is a cosmic masterpiece that continues to inspire awe and wonder in all who gaze upon it. As we continue to learn more about the nebula and its formation, we are reminded that the universe is a vast, mysterious place, full of intricate patterns and processes that we are only beginning to understand. The study of nebulae like the Butterfly Nebula offers us a glimpse into the future of our own sun and the ultimate fate of our solar system. It is a reminder that we are part of an ever-evolving universe, where life, death, and rebirth are constant and interconnected. The Butterfly Nebula is not just a fascinating object of scientific study. It is a symbol of the beauty and complexity of the universe, and a reminder of the incredible forces at work in the cosmos. It is a cosmic butterfly in the final stages of its transformation, leaving behind a trail of gas and dust that will one day give birth to new stars, planets, and life. And in that sense, the Butterfly Nebula is not just a dying star. It is a symbol of the eternal cycle of creation and destruction that defines the universe. As we continue to explore the Butterfly Nebula, it becomes increasingly clear just how remarkable and significant this stellar death truly is. While its vibrant and intricate wings may seem like a beautiful, fleeting display, the processes that shape this nebula are far more complex than they first appear. Beyond the delicate contours of gas and dust lie the secrets of stellar evolution, the mechanics of dying stars, and the profound influence they have on the universe around them. One key factor in the formation of the Butterfly Nebula's shape is the role that the central star plays. This star, known as a white dwarf, is the remnant of a once massive star that has exhausted its nuclear fuel and shed its outer layers. What remains is a dense core of carbon and oxygen, no longer capable of sustaining nuclear fusion. As this star sheds its outer layers, the gas and dust spread outwards, forming a stunning display of light and matter that we observe as the nebula. However, the star's transition into a white dwarf is just the beginning of a fascinating process. It is important to understand that white dwarfs, unlike other stellar remnants, do not go on to collapse into more extreme objects such as neutron stars or black holes. Instead, they quietly fade away, radiating light for billions of years until they eventually cool to a point where they no longer emit any detectable radiation. This prolonged cooling phase is one of the most intriguing aspects of the life cycle of stars like the one at the center of the Butterfly Nebula. The fact that white dwarfs can persist for such a long time after the death of their parent star highlights the profound stability they possess despite their diminutive size. While the star itself may not undergo further dramatic changes, the materials it has expelled into space continue to evolve, creating a fascinating interplay of gases, elements, and cosmic forces. The shape of the Butterfly Nebula's wings, although symmetric in general structure, is influenced by a variety of factors, including the star's rotation, magnetic fields, and the dynamics of the surrounding environment. The asymmetry of the nebula's wings, often described as the butterfly shape, suggests that there are still forces at play that affect how the gas and dust are expelled. For instance, the star at the center may have a companion star, or it could be experiencing an interaction with nearby material. This interaction could explain the uneven shape of the nebula, with one lobe being more prominent than the other. The uneven nature of the expelled material could also be linked to the star's magnetic field, which might guide the gas and dust in a specific direction, further shaping the nebula's distinctive form. In addition to these physical forces, the chemical composition of the nebula continues to play an important role in its evolution. As the gases from the dying star interact with the surrounding environment, they will mix with other material, enriching the interstellar medium with new elements. These elements, such as carbon, nitrogen, and oxygen, are essential for the formation of new stars and planets. The Butterfly Nebula's contribution to the cosmic recycling process cannot be understated. The star's final act, its release of gases and dust, sows the seeds for the birth of new stars, and potentially, new planetary systems. The Butterfly Nebula, like many other planetary nebulae, also serves as a reminder of the vast timescales involved in stellar evolution. A single star's life cycle spans billions of years, and yet, in the grand scheme of things, the nebula formed by the star's death is just a brief moment in time. The nebula will eventually dissipate as the material spreads out across the cosmos, slowly blending with the interstellar medium and contributing to the next generation of stars. The entire process of star formation, death, and rebirth is a cosmic cycle that repeats itself endlessly, contributing to the ongoing evolution of galaxies, star systems, and the universe itself. As stars die, they create the conditions necessary for new stars to form, ensuring that the cycle continues. The Butterfly Nebula is but one chapter in this never-ending story, a testament to the dynamic processes at work in the universe. As we continue to study this nebula, we learn more about the nature of dying stars and the processes that shape the universe. The nebula serves as a cosmic laboratory where scientists can test their theories about the behavior of stars, the dynamics of gas and dust, and the ways in which the elements that make up the universe are distributed throughout space. Each observation, each new discovery, helps us piece together a more complete picture of the universe's origins, its current state, and its eventual fate. One of the most intriguing aspects of the Butterfly Nebula is the way it exemplifies the concept of cosmic recycling. Stars, which are born in massive clouds of gas and dust, eventually die, releasing their material back into space. This material then becomes part of new molecular clouds, which give birth to new stars. The gas and dust from dying stars contribute to the formation of planets, moons, and other objects in space. In this way, stars are not just isolated, individual entities. They are part of a vast, interconnected system of creation and destruction. This concept of cosmic recycling is central to our understanding of the universe. It highlights the interconnectedness of all things in the cosmos, from the smallest atoms to the largest galaxies. The death of one star leads to the birth of another, and the materials expelled during a star's final moments help shape the future of the universe. This process ensures that the cycle of stellar evolution continues, with each new generation of stars building upon the previous one. The Butterfly Nebula, in particular, serves as a striking visual reminder of this process. The intricate patterns of gas and dust, the glowing colors and delicate wings, all tell the story of a star's final moments. But these patterns are more than just beautiful. They represent the culmination of billions of years of stellar evolution. The elements within the nebula, elements like carbon, oxygen, and nitrogen, were once forged in the heart of a massive star, and now they are being spread throughout the galaxy, ready to contribute to the formation of new stars and planets. In this sense, the Butterfly Nebula is both an end and a beginning. It marks the death of one star, but it also serves as the foundation for future star systems. This cyclical nature of the universe, where death gives way to new life, is one of the most awe-inspiring aspects of the cosmos. It reminds us that the universe is constantly changing, constantly evolving, and that everything, even the death of a star, plays a role in shaping the future. As we look at the Butterfly Nebula, we are reminded that the universe is full of mysteries waiting to be uncovered. Each nebula, each star, each planet, holds clues about the past, present, and future of the cosmos. By studying these objects, we are able to learn more about the forces that shape the universe and the processes that govern the formation of stars, galaxies, and planetary systems. But perhaps most importantly, the Butterfly Nebula reminds us that we are part of something much larger than ourselves. We are all made of stardust, the remnants of stars that have lived and died long before we ever existed. The elements that make up our bodies, the air we breathe, the water we drink, these were once forged in the hearts of stars. The universe is not just a vast and distant place. It is intimately connected to our existence, and the cycles of stellar evolution are what ultimately allow life to flourish on planets like our own. The Butterfly Nebula is not just a stunning object in the sky. It is a symbol of the interconnectedness of all things in the universe. It is a reminder that life, death, and rebirth are constant, and that every moment in the life of a star, no matter how fleeting, contributes to the larger story of the cosmos. And as we continue to study and explore the universe, we will undoubtedly uncover even more mysteries, each one bringing us closer to understanding the vast and beautiful forces that shape our existence. As we continue our exploration of the Butterfly Nebula, we now delve deeper into the science behind its mesmerizing features. Beyond its beauty lies an intricate dance of forces, physics, and time. Understanding the fundamental processes that lead to the formation and the eventual demise of such a nebula will help us appreciate the depth of its significance. One of the most compelling aspects of the Butterfly Nebula is its complex composition, which has revealed much about the final stages of a star's life. The central star at the heart of the nebula is a white dwarf, which has undergone an intense transformation. White dwarfs are the remnants of stars that once resembled our Sun but have shed their outer layers after exhausting their nuclear fuel. Unlike more massive stars that may end their lives in supernovae, a white dwarf simply expels its outer layers, leaving behind a dense core. This core continues to radiate heat and light for millions, even billions, of years, but it no longer produces any nuclear fusion. At the moment of a star's death, the expelled material forms what is known as a planetary nebula, a cloud of gas and dust. The Butterfly Nebula, with its distinctly beautiful, wing-like shape, is a prime example of this phenomenon. It's a stellar graveyard, showcasing the final breath of a star. The nebula's formation, which can take thousands of years to fully manifest, occurs in stages. Initially, the star expands into a red giant, shedding layers of gas into space. These layers then form a gaseous shell around the star, creating a dense, colorful nebula that we observe from Earth. What makes the Butterfly Nebula particularly interesting is its structure. The symmetrical, wing-like shape is not a coincidence, and scientists believe it is a result of the star's rotating motion, magnetic fields, and the dynamics of the surrounding environment. The magnetic fields of the white dwarf, which have a strong influence on the gas and dust around it, help shape the nebula's final form. This magnetic influence can create an even distribution of material, but because of the rotational motion of the central star, the material is often ejected in a direction that forms asymmetrical lobes. This is why we see the nebula's distinctive, butterfly, shape, with two larger lobes of gas flanking a smaller, dense core. In addition to the magnetic forces and rotation, other factors also come into play in determining the shape and size of the nebula. The presence of nearby stars, particularly a companion star or other stellar remnants, can significantly influence the nebula's shape. For example, the gravitational interaction between the central white dwarf and any nearby objects could cause disturbances in the material being ejected, leading to asymmetries in the nebula's wings. In some cases, the interaction of these stellar remnants with surrounding interstellar material can create a more intricate and complex structure, with gas and dust swirling around in ways that are not immediately visible. A key component of the Butterfly Nebula is its interaction with the interstellar medium. The gas and dust that make up the nebula eventually mix with the material between stars, enriching the interstellar medium with heavier elements such as carbon, oxygen, and nitrogen. This process of chemical enrichment is crucial to the formation of new stars, planets, and even life. The material ejected by dying stars serves as the building blocks for future generations of stars and planetary systems. Over time, these elements may be incorporated into the molecular clouds that eventually give birth to new stars. The nebula's evolution doesn't end with the release of gas and dust. The forces at work in the nebula continue to shape its future for millions of years. As the gas expands outward, it cools, and the material begins to dissipate into the surrounding space. Eventually, the nebula fades from view, leaving behind only the faint, lingering traces of the once vibrant star. The nebula may eventually blend with the interstellar medium, merging with the material that fills the vast emptiness between stars. This dispersal of material marks the conclusion of the nebula's life, but in reality, it is simply another phase in the ongoing cycle of stellar birth, death, and rebirth. The cooling and fading of the Butterfly Nebula marks the final stage of its existence as a nebula. However, the central white dwarf will continue to shine for billions of years, radiating heat and light as it slowly cools. This cooling process, which takes place over an extraordinarily long time, is one of the most fascinating aspects of white dwarfs. Over time, the white dwarf will lose its ability to emit light, transitioning into what is known as a black dwarf. At this point, the star will no longer be visible to telescopes, and it will be just another cold remnant floating through the vastness of space. As the Butterfly Nebula fades into the background of space, its legacy endures. The material it has released into the universe will play a crucial role in the formation of new stars, planets, and even life. The stars that are born from the gas and dust created by the nebula will carry forward the legacy of the original star, continuing the cosmic cycle of creation and destruction. The nebula serves as a reminder of the impermanence of life, not just on Earth but throughout the universe. Stars, like all things, have a beginning, a middle, and an end. But their death is not the end of the story, it is merely a transition to something new. The story of the Butterfly Nebula is not just one of death, it is a story of transformation, of the ongoing cycle of creation and destruction that defines the universe. It is a testament to the dynamic, ever-changing nature of the cosmos. As we look at this incredible nebula, we are reminded that the universe is constantly evolving, constantly shifting, and that every death is followed by new life. The gas and dust that once made up a star now form the building blocks for future generations of stars and planets. In the grand scheme of things, the Butterfly Nebula is just one example of the countless stellar remnants scattered throughout the universe, each playing a part in the continuous cycle of stellar evolution. As we gaze at this nebula, we are not just observing a dying star but a living, breathing part of the universe's vast, interconnected system. The nebula is a living reminder of the incredible processes that shape the cosmos, processes that are both awe-inspiring and humbling. One of the greatest mysteries of space is the vastness of time involved in these processes. While human lifespans may be measured in decades or centuries, the life cycles of stars unfold over billions of years. This is an astonishing reminder of the true scale of the universe, vast, slow-moving, and yet full of intricate beauty and precision. The Butterfly Nebula, with its delicate wings of gas and dust, represents a fleeting moment in the grand timeline of the cosmos. Its beauty, though temporary, will resonate through the universe for eons to come. It's also important to recognize that the Butterfly Nebula, like other nebulae, is a product of both time and space. The location of the nebula within the universe and its proximity to other cosmic phenomena play a crucial role in shaping its final form. The forces at play within our universe, from gravity to magnetism, from radiation to stellar winds, all contribute to the nebula's stunning structure. Each element of the nebula, from the smallest atom to the largest gas cloud, is a testament to the forces of nature at work, forces that we are only beginning to understand. Through continued observation and study of nebulae like the Butterfly Nebula, we can begin to piece together the story of the universe, how stars form, live, and die. But even as we uncover these details, we are reminded that there is so much more to discover, so many more mysteries to unravel. The universe, with all its beauty and complexity, is still full of questions, and the Butterfly Nebula is just one of many answers waiting to be uncovered. As we continue our exploration of the Butterfly Nebula, it's essential to understand that this fascinating phenomenon serves as a window into not only the life cycles of stars but also into the broader processes that govern the universe. While the Butterfly Nebula may appear as a stunningly beautiful object in the night sky, its formation is the culmination of a series of extremely complex physical interactions that span across billions of years. We are privileged to witness the end of one chapter in the universe's ongoing story, but it also raises deeper questions about what happens in the vastness of space, what drives these cycles of birth, death, and rebirth, and how life as we know it fits into this grand cosmic picture. The nebula itself, located in the constellation of Scorpius, is roughly 3,800 light-years away from Earth. From this immense distance, its wings spread out over an area of about 2 light-years across, making it a truly gigantic structure. But despite its immense size, the nebula is still an ephemeral phenomenon. The gas and dust that make up the nebula are constantly expanding and dissipating into the interstellar medium. Over time, the nebula will eventually fade away, becoming indistinguishable from the surrounding space. This slow transformation reflects the cyclical nature of stellar death. A star's death is both an end and a beginning. As we examine the nebula's composition, it becomes clear that the gases that form it are a mixture of elements, primarily hydrogen and helium, but also heavier elements like oxygen, nitrogen, carbon, and sulfur. These elements are the very building blocks of the universe. They are the same elements that make up our own bodies, our planet, and everything we know. The death of a star, such as the one that formed the Butterfly Nebula, contributes to the continuous recycling of matter within the cosmos. Through this process, stars enrich the interstellar medium, providing the raw materials for new stars, planets, and even life itself. Understanding how stars like the one at the center of the Butterfly Nebula reach the end of their life cycle requires delving into the process of stellar evolution. Stars are born from clouds of gas and dust known as molecular clouds. These clouds collapse under their own gravity, leading to the formation of protostars. As the protostar heats up, nuclear fusion begins, and the star enters the main sequence phase of its life, where it spends the majority of its time. During this phase, the star generates energy by fusing hydrogen into helium in its core. Eventually, the star runs out of hydrogen fuel, and the fusion process slows. The core contracts, and the outer layers expand, turning the star into a red giant. As the star's outer layers are expelled, they form a shell of gas and dust surrounding the core. The central core, which is no longer undergoing fusion, becomes a white dwarf. This white dwarf is incredibly dense and hot, but it is no longer able to sustain fusion reactions. Over the course of billions of years, the white dwarf will gradually cool and fade. The expulsion of the star's outer layers during this red giant phase is what creates nebulae like the Butterfly Nebula. The gas and dust that are cast off into space form intricate, often symmetrical shapes. The exact form of the nebula is influenced by several factors, including the rotation of the star, magnetic fields, and the dynamics of the surrounding space. In the case of the Butterfly Nebula, the star's rotational motion combined with its magnetic fields has created the distinctive, winged shape, which gives it its name. As we continue to study the Butterfly Nebula, we learn more about the complex forces at play. The central white dwarf, as mentioned earlier, has a strong magnetic field that helps to shape the nebula's structure. This magnetic field influences the behavior of the gas and dust surrounding the star. The rotation of the white dwarf also plays a significant role in the nebula's shape. As the white dwarf spins, it creates a wind of particles that expels material in opposite directions, forming the two lobes that give the nebula its butterfly-like appearance. Beyond these local forces, the Butterfly Nebula also interacts with the larger cosmic environment. The interstellar medium, an almost empty space filled with gas, dust, and electromagnetic radiation, affects the behavior of the nebula. As the gas expands outward, it begins to interact with this medium. The energy from nearby stars, cosmic radiation, and even the gravitational pull from other stars or nebulae can all influence the nebula's expansion and shape. These interactions help create the dazzling colors and intricate patterns that we see in images of the Butterfly Nebula, from the glowing reds and greens to the wispy filaments of gas stretching out from the central star. But the Butterfly Nebula is not just a beautiful object in the sky. It is a laboratory for understanding the processes of stellar evolution, the fate of stars like our Sun, and the nature of the interstellar medium. Studying the nebula helps astronomers piece together the broader story of how stars live, die, and give rise to new stars. It also raises questions about the future of our own Sun. Like the star at the center of the Butterfly Nebula, our Sun will eventually exhaust its fuel and transform into a red giant. It will shed its outer layers, creating a planetary nebula and leaving behind a white dwarf, just like the one at the center of the Butterfly Nebula. As the material from the Sun mixes with the interstellar medium, it will contribute to the creation of future generations of stars and planets. Over billions of years, this cycle of star birth and death will continue, giving rise to new stars, new planets, and perhaps even new forms of life. The fate of our own solar system, though far in the future, is tied to this cosmic cycle, just as the Butterfly Nebula represents the end of one stellar life and the beginning of another. Beyond these scientific implications, the Butterfly Nebula also speaks to something deeper within us, the awareness that we are part of something much larger. The nebula serves as a reminder that we are all connected to the universe through the very elements that make up life. The oxygen we breathe, the carbon in our bodies, and the nitrogen that sustains life on Earth all come from stars that lived, died, and left their mark on the cosmos. The Butterfly Nebula, in all its beauty, is a symbol of this ongoing cycle, a symbol of transformation, renewal, and the vast interconnectedness of everything. As we continue to look at the Butterfly Nebula, we can't help but wonder about the countless other nebulae scattered throughout the universe. Each one tells its own story, of a star's life, death, and rebirth. While the Butterfly Nebula is one of the most well-known examples, it is just one of many nebulae that dot the vast expanse of space. These nebulae represent the end of one stellar cycle, but also the beginning of something new. They are the cosmic cemeteries, but also the birthplaces of new stars and planets. In a sense, each nebula is a chapter in the ever-unfolding story of the universe. The more we study the Butterfly Nebula and similar objects, the more we uncover about the fundamental processes that govern the cosmos. With advanced telescopes and space probes, we are now able to study these nebulae in unprecedented detail. Our understanding of their structure, composition, and the forces at work continues to deepen, opening up new avenues for exploration and discovery. As we peer into the depths of space, we are reminded that there is still so much to learn and so much to discover about the universe and our place within it. As we continue to explore the mysteries of the Butterfly Nebula, it's worth highlighting how this magnificent nebula exemplifies the broader principles of astrophysics and cosmology. Nebulae like the Butterfly Nebula hold clues about the origins of the universe and the fundamental processes that shape everything from the smallest particles to the largest structures in the cosmos. By understanding these phenomena, astronomers and scientists can make better predictions about the future of stars, galaxies, and even our own planet. One of the most important aspects of the Butterfly Nebula is the role it plays in understanding stellar evolution and the death of stars. Our Sun, like the star that once occupied the center of the Butterfly Nebula, will eventually undergo a similar fate. Understanding the processes that govern this transition, from a vibrant star to a fading white dwarf surrounded by a nebula, gives us insights into the broader life cycle of stars. In the case of the Butterfly Nebula, the transition from the red giant phase to the expulsion of gas and dust is particularly intriguing. The star at its center was likely a red giant before it shed its outer layers, creating the nebula that we now see. As the star expanded, it began to lose its outermost layers through a process called stellar wind. These layers, composed of gases and heavier elements, were pushed out into space, leaving behind the white dwarf at the center. The white dwarf itself is an incredibly dense object. It is made up primarily of carbon and oxygen, the remnants of the star's core. Though it may be small in size, roughly the size of Earth, its mass is comparable to that of the Sun. The extreme density of the white dwarf means that a single teaspoon of its material would weigh several tons on Earth. Over time, as the white dwarf continues to cool and fade, it will eventually become a black dwarf, a cold, inert object that no longer emits light or heat. While the white dwarf in the Butterfly Nebula is slowly fading, the surrounding nebula is expanding outward, gradually dissipating into the interstellar medium. This process is a natural part of the life cycle of stars, but it's also essential for the creation of new stars and planets. The gas and dust expelled by dying stars provide the raw materials needed to form new stars, moons, and planets. This cycle of death and rebirth is one of the fundamental aspects of the universe's evolution. As we look at the structure of the Butterfly Nebula itself, we notice a variety of intricate features that speak to the complex forces shaping it. The two lobes of gas and dust that form the wings of the butterfly are the most prominent features of the nebula. These lobes are the result of the star's magnetic fields and the interplay between the stellar wind and the surrounding material. The magnetic field at the center of the white dwarf is incredibly strong, and it channels the expelled material along two distinct axes, forming the wings of the nebula. In addition to the magnetic fields, the nebula's structure is also influenced by the rotation of the white dwarf. As the star spins, it creates a wind of particles that is expelled from the star's poles. This wind carries with it the gases and dust from the outer layers of the star, creating the symmetrical lobes that define the nebula's appearance. The result is a nebula with a well-defined shape, almost like the wings of a butterfly stretching out into space. As the gas and dust expand outward, they encounter the interstellar medium, the diffuse material that exists between stars. The interaction between the nebula and the interstellar medium is a key factor in the nebula's expansion and eventual dissipation. The energy from nearby stars, cosmic radiation, and the gravitational influence of other objects can all affect the behavior of the nebula. Over time, the gases that form the nebula will mix with the surrounding space, eventually becoming part of the larger cosmic ecosystem. One of the most fascinating aspects of the Butterfly Nebula is the stunning colors that are visible in images taken by telescopes such as the Hubble Space Telescope. These colors are the result of different gases in the nebula emitting light at specific wavelengths. The most prominent colors in the Butterfly Nebula are red, green, and blue, each corresponding to a different element. The red color in the nebula is primarily caused by the presence of hydrogen. Hydrogen is the most abundant element in the nebula, and it emits light in the red part of the spectrum when it is ionized by the intense radiation from the central white dwarf. The green color is due to the presence of oxygen, which emits light in the green part of the spectrum. The blue hues come from the emission of nitrogen and other elements, which are present in smaller quantities but still contribute to the overall visual display. These vibrant colors give the Butterfly Nebula a surreal and otherworldly appearance, making it one of the most visually striking objects in the sky. The nebula's intricate patterns, combined with the glowing colors, make it a favorite subject for astronomers and astrophotographers alike. It's a reminder that the universe is not only vast and mysterious, but also incredibly beautiful in its complexity. The study of the Butterfly Nebula also has practical implications for our understanding of other nebulae and stellar remnants throughout the universe. By comparing the Butterfly Nebula to other planetary nebulae, astronomers can better understand the processes that govern stellar death and the formation of white dwarfs. This knowledge is crucial for understanding the fate of stars like our Sun, which will eventually go through a similar process of shedding its outer layers and leaving behind a white dwarf. Moreover, studying nebulae like the Butterfly Nebula helps us understand the broader cosmic cycle that governs the universe. The elements produced by dying stars are crucial for the formation of new stars, planets, and even life. The heavy elements such as carbon, oxygen, and nitrogen that are expelled during stellar death are the building blocks for future generations of stars and planets. Without these elements, life as we know it would not be possible. As we continue to observe the Butterfly Nebula and similar objects, we gain a deeper understanding of the universe and our place within it. The nebula is not just a beautiful object to behold, It is a symbol of the ongoing process of creation and destruction that defines the cosmos. It serves as a reminder that the universe is constantly evolving, with new stars and planets being born even as old ones die. In this way, the Butterfly Nebula is both a testament to the past and a glimpse into the future, offering a window into the dynamic processes that shape the universe. In the coming decades, as new space telescopes are launched and our technology continues to advance, we will likely uncover even more secrets about nebulae like the Butterfly Nebula. Our understanding of stellar death, the formation of white dwarfs, and the role of nebulae in the cosmic cycle will continue to evolve. With each new discovery, we will gain a deeper appreciation for the incredible beauty and complexity of the universe around us. As we delve even further into the Butterfly Nebula's profound mysteries, it's important to consider its place in the larger context of space exploration. The sheer magnificence of this nebula serves not just as a beautiful sight for astronomers, but also as a critical benchmark for studying the life cycle of stars across the cosmos. When we gaze upon the nebula, we are not simply looking at a distant and colorful cloud of gas and dust. We are observing the results of processes that mirror what will eventually happen to our own sun. This brings us to an interesting point. While the nebula's current state is one of beauty, it is also a reminder of the inevitable cycle of birth, life, and death that defines the cosmos. Our sun, currently in the middle of its life cycle, will one day expand into a red giant and eventually expel its outer layers. This is a fate shared by countless stars, whose deaths give birth to the interstellar material that forms future stars, planets, and other celestial bodies. These processes are what we refer to as the stellar nursery, a cosmic cycle that continuously shapes the universe, turning one generation of stars into the next. In this respect, the Butterfly Nebula is not unique. It is a perfect example of a common astrophysical phenomenon that occurs throughout the universe. Planetary nebulae, like the Butterfly Nebula, form when a star similar to our Sun reaches the end of its life and sheds its outer layers, leaving behind a dense white dwarf. These types of nebulae are found all over the Milky Way galaxy, but the Butterfly Nebula stands out due to the complexity and symmetry of its structure. The perfect butterfly shape is a rare and captivating feature that has intrigued astronomers for years. The orientation of its wings, the symmetry of its shape, and the highly detailed structure within each lobe create a nearly unparalleled spectacle. The role that the Butterfly Nebula plays in our understanding of stellar death cannot be overstated. It is one of the clearest examples of how a star's final stages of life give birth to new structures in space. After the star expels its outer layers, these gases mix with the surrounding space, creating nebulae that can stretch across light years. The remnants of these stellar explosions, carbon, nitrogen, oxygen, and other heavy elements, are essential for the formation of new stars and planets. This continual cycle of matter recycling is what enables the evolution of galaxies and solar systems, providing the raw materials necessary for the formation of stars, planets, and even life as we know it. The intricate structure within the Butterfly Nebula also speaks to the variety of forces at play within the nebula's formation. While the white dwarf at the center of the nebula is responsible for ionizing the surrounding gases and creating the glowing colors we see, it's the magnetic fields and stellar winds that shape the nebula's structure. The magnetic field of the white dwarf creates two distinct lobes of gas that extend outward in a symmetrical pattern, almost like the wings of a butterfly. This process occurs over thousands of years, with the gases gradually expanding outward until they are eventually dispersed into the interstellar medium. Another fascinating aspect of the Butterfly Nebula is the role that its central white dwarf plays in its evolution. Though it may seem like a small and inert object compared to the star it once was, the white dwarf is far from inactive. It remains incredibly dense and hot, still emitting radiation that helps to ionize the surrounding gases. The radiation emitted by the white dwarf, combined with the intense winds of gas escaping from the star, plays a key role in shaping the nebula's final form. As the gases are expelled and ionized, they begin to glow with a brilliant light, creating the stunning visual display that we see from Earth. The study of planetary nebulae like the Butterfly Nebula provides critical insight into the life cycle of stars. By observing the processes at work in these nebulae, scientists can better understand the mechanisms that drive stellar evolution. This knowledge is crucial not just for understanding the past and future of stars in our own galaxy, but also for studying distant galaxies and star systems. By learning more about the way stars die and form nebulae, astronomers can make more accurate predictions about the fate of stars and other parts of the universe. It's also important to note that the Butterfly Nebula's location within the constellation of Scorpius is another reason why it's so fascinating. Scorpius is a region of the sky rich in stars, nebulae, and other astronomical phenomena. The Butterfly Nebula resides near the heart of this constellation, making it one of the most prominent features in the region. As a result, it has become a key object of study for astronomers seeking to understand the stellar processes that take place within this part of the galaxy. The Butterfly Nebula's striking appearance has made it a favorite target for astronomers using some of the most advanced telescopes on Earth and in space. In particular, the Hubble Space Telescope has provided some of the most detailed images of the nebula, revealing its intricate structure and vibrant colors in stunning detail. The ability to study such a complex object in such detail is a testament to the incredible advancements in astronomical technology over the past few decades. Looking ahead, the study of the Butterfly Nebula will continue to yield valuable insights into the nature of stellar death, planetary nebulae, and the evolution of stars. As telescopes improve and more data is collected, we may uncover even more secrets hidden within this extraordinary nebula. The more we learn, the more we realize how much there still is to discover in the vast, unexplored expanse of space. Furthermore, the study of objects like the Butterfly Nebula has the potential to answer some of the most fundamental questions about the universe. For example, scientists are still working to understand the full range of processes that govern the death of stars and the formation of planetary nebulae. The mysteries of stellar winds, magnetic fields, and the interactions between gas and dust are far from fully understood. By studying the Butterfly Nebula and similar objects, scientists can continue to refine their models of stellar evolution and better understand the complex forces that shape the universe. The Butterfly Nebula is much more than just a stunning visual phenomenon. It is a window into the life cycle of stars, a testament to the vast forces at play in the universe, and a critical object for astronomers seeking to understand the evolution of galaxies and solar systems. Its beauty and complexity make it one of the most fascinating nebulae in the sky, offering a glimpse into the final stages of a star's life and the processes that will eventually occur with our own sun. As our understanding of space continues to evolve, objects like the Butterfly Nebula will remain key players in unlocking the mysteries of the cosmos. From its mesmerizing colors to its intricate structure, the nebula offers both scientific and aesthetic insights that help us appreciate the grandeur of the universe in which we live. With each new discovery, we move closer to understanding the mechanisms that drive the birth, life, and death of stars, and how those processes shape the very fabric of the cosmos itself. The Butterfly Nebula, a cosmic masterpiece, continues to inspire curiosity and awe as we continue to explore the vastness of space. The Butterfly Nebula, like many other planetary nebulae, is a powerful reminder of the cyclical nature of the universe. The death of stars is not the end of their legacy. Rather, it is the beginning of a new chapter in the cosmic story. The gases and particles expelled by dying stars create new opportunities for future generations of stars to form, leading to the continuous evolution of the cosmos. In this way, the nebula serves as a cosmic recycling center, taking the remnants of one star and using them to seed the next generation of celestial bodies. It's fascinating to think about how this process of star death and rebirth connects not just to the cosmic scale, but to the very nature of our existence. The elements that make up our bodies, our planet, and everything we know were once forged in the cores of stars. As stars like the one that created the Butterfly Nebula explode and release their material into the universe, those elements find their way into new stars, planets, and eventually, life itself. We are all made of stardust, and understanding how stars live and die brings us closer to understanding our place in the vast, interconnected universe. While the Butterfly Nebula is undoubtedly a symbol of beauty and wonder, it also offers profound insight into the laws of physics and the processes that govern the universe. The way its symmetrical structure is formed by the interaction of magnetic fields, stellar winds, and radiation offers a glimpse into the complex mechanisms that operate within the hearts of dying stars. These processes, once understood, can shed light on how similar phenomena might occur in other parts of the universe, leading to further discoveries that can enhance our knowledge of stellar evolution. The ongoing study of the Butterfly Nebula has also revealed some surprising aspects of the phenomenon. For instance, the fact that the nebula's structure is so symmetrical suggests that its formation was not a random event. Instead, it points to the involvement of specific forces and interactions that led to the creation of such a precise shape. This challenges some of our previous assumptions about the randomness of nebula formation, showing that in some cases, the death of stars can lead to incredibly ordered and beautiful structures. This new understanding helps astronomers refine their models of how stars die and the forces that shape their remains. In terms of the nebula's longevity, it's important to note that planetary nebulae like the Butterfly Nebula don't last forever. Over time, the gas and dust that make up the nebula will dissipate into the surrounding space, gradually becoming less visible to observers. This process can take thousands to tens of thousands of years, and eventually, all that will remain of the nebula will be the white dwarf at its center. The nebula's fading over time serves as a reminder that even the most awe-inspiring objects in the universe are subject to the same laws of decay and transformation that govern all things in the cosmos. As the nebula gradually disappears, it leaves behind a lasting legacy in the form of the material it has released into space, ready to be recycled into the next cycle of star formation. In many ways, the Butterfly Nebula mirrors the story of all stars, an ongoing cycle of birth, life, death, and rebirth. This cyclical nature is fundamental to the universe's operation, allowing for the continual evolution of galaxies, stars, and planetary systems. By observing and studying objects like the Butterfly Nebula, scientists are able to piece together the vast, interconnected network of cosmic processes that shape the universe. Each star that dies and forms a nebula, each supernova that releases elements into space, and each black hole that pulls matter into its singularity contributes to the ever-expanding understanding of how the cosmos functions. Looking forward, the study of the Butterfly Nebula, and planetary nebulae in general, could provide key answers to some of the biggest questions about the universe. For example, scientists are still working to understand the exact role that magnetic fields play in shaping the structures of nebulae. Some of the nebulae we observe seem to have intricate, symmetrical patterns that suggest a deeper connection to the forces at play within the star that gave birth to them. Understanding the interaction between magnetic fields, stellar winds, and ionized gases could unlock new insights into the evolution of stars and nebulae, and may even lead to the discovery of previously unknown astrophysical phenomena. Additionally, as we continue to refine our observation techniques, we may begin to uncover even more hidden details within the Butterfly Nebula. With advanced telescopes like the James Webb Space Telescope offering unprecedented levels of clarity and resolution, astronomers may soon be able to observe the nebula in ways that were previously impossible. The fine details of the nebula's gas structures, the precise nature of its radiation emissions, and the interactions between the various components could provide further revelations about how the nebula formed and how it will eventually fade away. The exploration of nebulae like the Butterfly Nebula also has broader implications for our understanding of the universe's larger structure. Studying the remnants of dead stars can give us insights into the history of our galaxy, and even the origins of life itself. By understanding how stars die and how their material contributes to the formation of new stars and planets, we can piece together a better picture of how the universe evolves. The elements that make up our bodies, the air we breathe, and the earth beneath our feet were all once part of a star, and understanding the processes that lead to the formation of those elements can help us understand the origins of life on our planet. The Butterfly Nebula is not just a cosmic wonder, it is a testament to the beauty and complexity of the universe itself. It represents the incredible forces that govern the creation and destruction of stars, and the deep interconnectedness between all things in the cosmos. By studying this nebula, we gain not only a greater appreciation for the visual splendor of space but also a deeper understanding of the fundamental processes that shape our universe. The more we learn about the Butterfly Nebula, the more we realize that its beauty is not just skin-deep, It is a reflection of the profound and intricate workings of the universe that continue to unfold before our eyes. As we continue to explore the vast reaches of space, objects like the Butterfly Nebula will remain key to unlocking the mysteries of the cosmos. From the life cycle of stars to the evolution of galaxies, the nebula offers a glimpse into the fundamental workings of the universe. As we look to the future, the study of such objects will no doubt continue to inspire awe, curiosity, and a deeper connection to the vast and ever-changing universe that we call home. The Butterfly Nebula is more than just a striking visual phenomenon. It holds critical information that could help explain the behavior of other similar cosmic structures scattered across the universe. The interplay between radiation, magnetism, and material expulsion within the nebula is a microcosm of the intricate processes that drive stellar evolution. The symmetry of the nebula's shape, the delicate yet powerful forces that created it, and the way it tells the story of a dying star's final moments are all part of a broader cosmic narrative that stretches across space and time. To truly appreciate the importance of this nebula, it's necessary to examine not just the physical features we can observe but also the theoretical implications. The Butterfly Nebula offers critical insights into the types of environments that exist near dying stars and provides clues as to how the energy, dust, and gases are distributed in these regions. Scientists who study planetary nebulae like the Butterfly Nebula have to grapple with the complexity of stellar winds, ionized gases, and other factors that contribute to the nebula's shape and behavior. In many ways, understanding these phenomena could provide key breakthroughs in astrophysics. One of the most interesting features of the Butterfly Nebula is its distinct bilobed shape, which stands out from other nebulae of its type. This symmetry has led researchers to propose that the nebula's unique form is the result of the star's magnetic field. These magnetic fields are often invisible to our eyes, yet they shape much of the universe's structure and behavior. In the case of the Butterfly Nebula, it is thought that the magnetic field of the dying star is guiding the ejected material into two lobes. This creates a butterfly-like shape, which serves as a testament to the influence of invisible forces that govern the universe. The presence of magnetic fields in stellar environments is not new to astronomers, but the Butterfly Nebula is one of the clearest examples of how these fields can influence the final stages of a star's life. Understanding how magnetic fields interact with the gases expelled by dying stars could have broad applications, potentially helping to explain other phenomena in astrophysics. For example, astronomers are particularly interested in the role magnetic fields play in shaping the mass loss from stars and influencing the surrounding space environment. Moreover, the Butterfly Nebula also opens doors to understanding the way in which dying stars contribute to the creation of new stellar material. Stars are the primary factories for the elements that make up the universe, and the process of stellar death plays a major role in the recycling of these materials. The gases and elements expelled from a dying star provide the raw materials for the formation of new stars, planets, and even life. In this way, the Butterfly Nebula becomes a symbol of both destruction and creation, destroying the star at its core while simultaneously enriching the universe with the elements necessary for new stars and planets. This cyclical process is a fundamental feature of the universe. Stars go through life cycles, from birth to death, and in doing so, they continually contribute to the evolution of the cosmos. The Butterfly Nebula, as an example of a planetary nebula, is a reminder that nothing in the universe is permanent. Just as stars are born from cosmic clouds of gas and dust, they eventually die and return their material to the universe, where it will become part of something new. A star's death may mark the end of its individual existence, but it also acts as a turning point in the universe's ongoing process of rebirth. The material that is expelled into the nebula serves as the building blocks for the next generation of stars and planets. It's not just the physical remnants of the star that live on. The elements formed in the star's core, such as oxygen, carbon, nitrogen, and even heavier elements like gold and uranium, are scattered across space, waiting to be incorporated into new cosmic structures. These elements are what make up the matter that forms planets, moons, and life, offering a deep connection between the death of a star and the creation of the future universe. This realization brings a profound sense of perspective. The stars we observe in the night sky, including the sun, are themselves part of this grand cycle of life, death, and rebirth. They are not eternal, but their legacy lives on in the elements they create and the new stars and planets they help to form. The Butterfly Nebula is just one example of this eternal cycle, a reminder that the universe is constantly evolving, with new stars being born from the remains of their predecessors. As we continue to look into the future of space exploration, we can expect even greater discoveries and revelations about objects like the Butterfly Nebula. The continued advancement of telescopes and space probes will allow us to observe these phenomena in more detail than ever before. Instruments like the James Webb Space Telescope, with its ability to peer into infrared wavelengths, will allow scientists to explore planetary nebulae like the Butterfly Nebula with unprecedented clarity. This could reveal even more intricate details about the nebula's structure, the chemical composition of its gases, and the forces at work in its creation. One area of particular interest to astronomers is how planetary nebulae like the Butterfly Nebula impact their surrounding environments. The outflow of material from a dying star can have a significant impact on the interstellar medium, the space between stars. This material, which consists of gas, dust, and other particles, is not only recycled back into the formation of new stars, but it also plays a critical role in the development of future planetary systems. Understanding how planetary nebulae interact with their environments could help scientists understand how galaxies, stars, and even life itself are influenced by these cosmic events. Furthermore, the Butterfly Nebula may offer more insights into the types of stars that produce such stunning visual displays in their death throes. Most planetary nebulae are created by medium-sized stars, those with a mass comparable to or slightly greater than our Sun. However, as we delve deeper into the study of these objects, we may uncover important differences between nebulae created by different types of stars. Understanding how stars of varying sizes die and the kind of material they expel could provide valuable information about the diversity of stars in the universe. At the same time, the study of the Butterfly Nebula also reinforces the idea that the universe is not just a collection of isolated stars and planets, but an interconnected system that operates according to fundamental laws. Stars give birth to new stars, nebulae become the breeding grounds for future celestial bodies, and the elements that make up everything we know are recycled throughout the cosmos. This intricate web of cosmic relationships highlights the profound interconnectedness of the universe and our place within it. The Butterfly Nebula is a remarkable and awe-inspiring object in the cosmos. It represents the final stage in the life of a star, showcasing the incredible forces at work in the universe's grand cycle of birth, death, and rebirth. Through its stunning shape and the beauty of its gaseous tendrils, the nebula captures the essence of cosmic transformation. It stands as a testament to the power of stars, the invisible forces that shape their deaths, and the materials they leave behind for the next generation of stars and planets. As we continue to study this nebula and others like it, we gain not only a greater appreciation for the universe's vastness but also a deeper understanding of our own place within this magnificent, ever-changing cosmos. The Butterfly Nebula remains one of the most studied and captivating phenomena in the universe. Its striking, symmetrical shape, which evokes the wings of a butterfly, is not merely an aesthetic curiosity. It is the result of intense and complex forces working together in the final moments of a star's life. These forces are a cosmic dance of matter and energy that not only shape the nebula's form but also provide vital clues about the nature of stellar evolution and the ultimate fate of stars similar to our Sun. The nebula's unusual bilobed shape invites deeper questions about the underlying mechanisms at play. Astronomers and astrophysicists have proposed that the butterfly-like structure is the result of a combination of factors, chief among them the star's rotation and its magnetic field. The idea is that the star, in its final stages, expels vast amounts of material, but these particles are not ejected in random directions. Instead, the expelled gas and dust are shaped into two lobes by the powerful magnetic fields surrounding the dying star. These fields create a sort of funnel, channeling the material along specific pathways, thus contributing to the distinct butterfly shape of the nebula. This interaction between a dying star's magnetic field and the surrounding material is an area of active research. The forces that produce the symmetry in the Butterfly Nebula could have implications for our understanding of other planetary nebulae and the behavior of dying stars across the universe. The magnetic fields at play here are invisible to the naked eye, but their effects are profound. Their role in shaping the nebula suggests that the influence of magnetic fields on stellar death may be more significant than previously thought, offering a new avenue for exploring stellar life cycles. Furthermore, the nebula's striking appearance tells only part of the story. The material that makes up the nebula, ionized gas and dust, provides a rich tapestry for scientists to study. The gases in the nebula are composed of elements such as hydrogen, helium, carbon, nitrogen, and oxygen, which were once fused in the core of the dying star. When the star begins to shed its outer layers, these elements are released into space, enriching the surrounding interstellar medium with the building blocks of new stars, planets, and eventually life. The Butterfly Nebula, like other planetary nebulae, plays a vital role in this cosmic recycling process. The gases and dust expelled by the dying star in the nebula contribute to what is often called the cosmic garden. This garden is a vast and ever-evolving collection of matter that eventually becomes part of new stars and planets. The elements released by stars in their final moments are what make up the physical world around us. Oxygen, for example, is one of the most essential elements for life as we know it, and its origins lie in the cores of long-dead stars that enrich the universe with it. By understanding how these elements are formed and distributed throughout space, scientists gain insights not only into the history of the cosmos but also into the potential for life elsewhere. The Butterfly Nebula also provides an exceptional opportunity to study the dynamics of stellar winds. Stellar winds are streams of charged particles that flow outward from a star, and these winds play a major role in shaping a nebula's appearance. The stellar winds from a dying star are extremely powerful, and they can interact with the surrounding interstellar material in a variety of ways. In the case of the Butterfly Nebula, these winds help to shape the nebula's symmetrical structure. The interaction between the stellar winds and the material expelled by the star also causes the gases to glow brightly, making the nebula visible to astronomers. Astronomers also study the Butterfly Nebula to understand the role that dying stars play in the larger context of galactic evolution. Stars that end their lives as planetary nebulae like this one are important contributors to the interstellar medium. As stars age and die, they return to the cosmos much of the material they once fused in their cores. This material is eventually incorporated into the formation of new stars, planets, and other celestial objects. In this sense, stars are not just self-contained entities. They are part of a larger, ongoing cycle that shapes the evolution of galaxies and the universe itself. The study of the Butterfly Nebula is also crucial for understanding the future of our Sun. While the Sun is currently in the middle of its life cycle, it is expected to undergo a similar transformation in about 5 billion years. As the Sun exhausts its nuclear fuel, it will begin to expand and eventually shed its outer layers, forming a planetary nebula. The Sun's death will lead to the creation of a similar nebula, albeit one that will differ in size and composition. Understanding the processes involved in the formation of nebulae like the Butterfly Nebula can help astronomers predict the eventual fate of our Sun and the solar system. In addition to providing insights into the life cycle of stars, the Butterfly Nebula is also an excellent laboratory for studying the properties of ionized gases and other cosmic materials. As a planetary nebula, it is an environment where astronomers can investigate the behavior of gases under extreme conditions. The temperatures and densities within the nebula vary greatly, and studying these conditions allows scientists to test theories about the behavior of matter in the final stages of stellar life. This kind of research helps to refine our understanding of fundamental physical processes such as the interaction between light, gas, and magnetic fields. With advancements in telescope technology, our understanding of the Butterfly Nebula continues to grow. Observatories around the world, including the Hubble Space Telescope, have provided high-resolution images of the nebula, revealing even more intricate details about its structure. The Hubble Space Telescope, in particular, has been instrumental in capturing the nebula's detailed features. These images not only allow scientists to study the physical properties of the nebula but also enable them to observe the intricate processes occurring within it. Future telescopes, such as the James Webb Space Telescope, which is set to launch soon, will offer even more powerful tools for studying objects like the Butterfly Nebula. The James Webb Space Telescope, with its ability to observe in infrared wavelengths, will allow scientists to peer deeper into nebulae, revealing structures and processes that are currently hidden from view. This will likely lead to new discoveries about the way planetary nebulae form and evolve, as well as provide further insights into the role they play in the larger cosmic landscape. The study of the Butterfly Nebula is part of a broader effort to understand the life cycle of stars and the role they play in the universe. Every dying star, whether it forms a planetary nebula or ends in a supernova, contributes to the ongoing evolution of the cosmos. These stars are the factories that create the elements that make up everything we see around us. The gas and dust expelled by stars provide the raw materials for the next generation of stars, planets, and even life. This continuous cycle of birth, death, and rebirth is what drives the evolution of galaxies and the universe itself. The Butterfly Nebula is just one small piece of this larger story, but its beauty and complexity serve as a reminder of the profound processes that govern the cosmos. It is a symbol of the intricate interplay between matter and energy, the forces that shape the universe, and the never-ending cycle of creation and destruction that drives the cosmos forward. The study of the Butterfly Nebula also raises intriguing questions about the nature of stellar evolution and how stars interact with their environments. One of the most striking features of the nebula is its well-defined structure, which contrasts sharply with the more chaotic, irregular shapes seen in other nebulae. The symmetry of the Butterfly Nebula, with its two distinct lobes extending outward, suggests that the processes involved in its formation are more complex than previously understood. It is well known that stars experience a number of stages throughout their lifetimes, but how they transition from one phase to another, particularly during their final stages, is still not fully understood. The Butterfly Nebula provides astronomers with a unique opportunity to study a star at the end of its life and to learn more about the forces that shape the evolution of stars. In particular, the nebula offers a glimpse into the processes that govern the mass loss of dying stars and how this mass is redistributed into the surrounding interstellar medium. The mass loss that occurs during a star's death is a crucial part of its life cycle. As stars burn through their fuel, they begin to shed their outer layers in the form of winds and gas clouds. This process is particularly important for stars like the one that created the Butterfly Nebula, which are in the late stages of their evolution. During this phase, the star's core contracts, and its outer layers expand outward. The star becomes a red giant, and the intense radiation pressure from the core pushes against the outer layers, causing them to be ejected into space. The material that is expelled from a dying star is rich in heavy elements, such as carbon and oxygen, that were created during the star's earlier life. These elements are released into space, where they become part of the interstellar medium. Over time, this material can contribute to the formation of new stars, planets, and even life. In this way, the death of a star can be seen as part of a larger cycle of cosmic recycling, where the elements created in the hearts of stars are returned to space to be used in the creation of new celestial bodies. The fact that the Butterfly Nebula is so well structured and symmetrical suggests that there are complex interactions at work between the dying star and its surroundings. It is likely that the star's magnetic field plays a significant role in shaping the nebula's shape. Magnetic fields are known to influence the motion of charged particles, and the shape of the Butterfly Nebula indicates that the magnetic field of the dying star is interacting with the gas and dust that surrounds it. These interactions create a funnel-like structure, channeling the expelled material into two distinct lobes. This idea is supported by the fact that many other planetary nebulae also exhibit symmetrical shapes, often with two lobes of material extending outward from the central star. This suggests that there is a common mechanism at work in the formation of these nebulae, likely involving the star's magnetic field. The Butterfly Nebula, with its striking symmetry, provides a detailed example of this process in action. In addition to the role of magnetic fields, the shape of the Butterfly Nebula may also be influenced by the rotation of the dying star. As stars rotate, they can generate powerful centrifugal forces that can affect the way their outer layers are expelled. In the case of the Butterfly Nebula, It is possible that the rotation of the star contributed to the formation of the two lobes by creating a more concentrated outflow of material along the star's equator. This would help explain the symmetry of the nebula, as the material would be expelled along two opposite directions, forming the distinctive butterfly wings. Another key factor in the formation of the Butterfly Nebula is the role of stellar winds. These winds are streams of charged particles that are constantly being ejected from stars. In the case of a dying star, the stellar wind is particularly strong, as the star sheds its outer layers. These winds play a critical role in shaping the nebula's appearance, as they push against the surrounding material and cause it to glow. The interaction between the stellar wind and the gas and dust in the nebula is what gives the nebula its characteristic brightness and color. One of the most remarkable aspects of the Butterfly Nebula is the way its gases and dust are illuminated. The nebula glows brightly because the gas is ionized by the radiation from the central star. When a star sheds its outer layers, the material is heated to extremely high temperatures by the intense radiation emitted by the star. This causes the atoms in the gas to become ionized, meaning that they lose or gain electrons and become charged. The ionized gas then emits light, which makes the nebula visible to astronomers. The colors of the nebula are also determined by the types of ions present in the gas. Different elements emit light at different wavelengths when they are ionized, and these wavelengths correspond to specific colors. In the case of the Butterfly Nebula, the gas contains a variety of elements, including hydrogen, oxygen, and nitrogen. The ionized hydrogen gives off a characteristic red color, while the ionized oxygen produces a greenish hue. The combination of these colors gives the nebula its striking appearance, with the red and green hues forming the wings of the butterfly. The study of the Butterfly Nebula is also important for understanding the future of our own Sunday. As mentioned earlier, the Sun will eventually evolve into a red giant and shed its outer layers, forming a planetary nebula. While the Sun's eventual transformation into a red giant is billions of years away, studying nebulae like the Butterfly Nebula allows scientists to gain insights into the processes that will shape the Sun's death. By studying the way other stars end their lives, astronomers can make predictions about the future of our own star and the solar system. The death of a star is a violent and dramatic event, but it is also a necessary one for the continued evolution of the universe. The elements created in the cores of stars are the building blocks of everything in the universe, from planets to life itself. The expulsion of these elements into space is what makes the formation of new stars, planets, and even life possible. In this sense, the death of a star is not an end but a beginning, the beginning of a new cycle of creation. The Butterfly Nebula serves as a striking reminder of the beauty and complexity of the universe. Its symmetrical shape, vibrant colors, and intricate details make it one of the most fascinating objects in the cosmos. But beyond its visual appeal, the nebula offers valuable insights into the processes that govern the evolution of stars and the way in which the death of a star contributes to the ongoing cycle of cosmic creation. By studying the Butterfly Nebula, scientists are able to learn more about the forces that shape the universe and the role that dying stars play in the ongoing evolution of the cosmos. As we continue to explore the mysteries of the Butterfly Nebula, it is important to delve into the broader implications of its discovery for our understanding of stellar death and the evolution of galaxies. The nebula's stunning beauty is not just a visual marvel, it is also a profound reminder of the intricate processes at play during the final stages of a star's life. The Butterfly Nebula is, in many ways, a cosmic laboratory that allows astronomers to study the most dynamic and dramatic events in the universe, shedding light on how stars reach their end and what becomes of the material they leave behind. One of the most fascinating aspects of the nebula is the sheer complexity of its structure. The central star, which has already gone through its red giant phase and is now in the process of shedding its outer layers, is surrounded by a wealth of intricate filaments of gas and dust. These filaments are shaped by various forces, such as the star's own radiation pressure, stellar winds, and the magnetic fields that may be present in the region. These forces work together to sculpt the gas and dust into the butterfly-like shape we see today, creating an awe-inspiring image of cosmic symmetry and order. The filaments of gas and dust in the Butterfly Nebula are not only visually striking, but they also hold important clues about the chemistry of the universe. As the star sheds its outer layers, the material it expels is rich in heavy elements such as carbon, oxygen, and nitrogen, that were created during the star's earlier life. These elements are essential for the formation of planets, life, and other stars. In fact, the very atoms that make up our bodies and the Earth itself were likely forged in the cores of ancient stars, and the Butterfly Nebula provides a direct link to this cosmic recycling process. By studying the composition of the gas and dust in the Butterfly Nebula, astronomers are able to learn more about the processes that occur within stars during their final stages. For example, the presence of certain elements in the nebula can provide insights into the nuclear fusion processes that took place within the star's core. The heavy elements found in the nebula were created during the star's lifetime, through a series of nuclear reactions that occur as the star burns through its fuel. These elements are then ejected into space when the star reaches the end of its life, enriching the interstellar medium with the building blocks for future stars and planets. In addition to shedding light on the composition of stars, the Butterfly Nebula also offers valuable information about the dynamics of stellar death. The nebula's structure is shaped by the intense stellar winds that are generated as the star sheds its outer layers. These winds, which are streams of charged particles, play a crucial role in the formation of planetary nebulae, as they help to push the material away from the star's core and into the surrounding space. The way in which these winds interact with the surrounding gas and dust can have a significant impact on the shape and size of the nebula, leading to the formation of complex, symmetric structures like the Butterfly Nebula. One of the most intriguing aspects of the nebula's structure is the apparent symmetry of its two lobes. This symmetry suggests that there may be an underlying mechanism at work, perhaps related to the star's magnetic field or its rotation, that is guiding the expulsion of material in such a way that it forms two distinct lobes. The exact cause of this symmetry is still a subject of active research, but it is clear that the interactions between the dying star and its environment are much more complex than simple mass loss alone. The magnetic field of the dying star is likely a key factor in shaping the nebula's structure. Magnetic fields can have a profound effect on the movement of charged particles, and they may be responsible for channeling the material expelled by the star into two distinct lobes. The magnetic field may also influence the way in which the gas and dust in the nebula interact with each other, leading to the formation of intricate patterns and filaments. The exact role of the magnetic field is still a subject of ongoing study, but it is clear that it plays an important role in the formation of planetary nebulae like the Butterfly Nebula. In addition to the star's magnetic field, the rotation of the star may also be contributing to the nebula's shape. As stars rotate, they create centrifugal forces that can push material away from their equator. This may help explain why the Butterfly Nebula has a well-defined, symmetrical structure, with two distinct lobes of material extending outward from the central star. The combination of magnetic fields, stellar winds, and the star's rotation likely works together to create the nebula's unique appearance. The study of the Butterfly Nebula also provides important insights into the future of our own Sun. While the Sun is not yet in the final stages of its life, it will eventually reach a point where it expands into a red giant and sheds its outer layers, much like the star that created the Butterfly Nebula. By studying nebulae like the Butterfly Nebula, astronomers can make predictions about what will happen when the Sun reaches the end of its life. The process by which the Sun will shed its outer layers and form a planetary nebula is still billions of years away, but by studying other stars that are going through this process, scientists can gain valuable insights into the fate of our solar system. The eventual death of our Sun will mark the end of its long life as a main sequence star. As it exhausts its nuclear fuel, the Sun will undergo a series of transformations that will lead to its expansion into a red giant. During this phase, the Sun's outer layers will be ejected into space, creating a planetary nebula. The material expelled by the Sun will be rich in elements such as carbon, oxygen, and nitrogen, which will become part of the interstellar medium. This material will eventually be recycled into the formation of new stars and planets, continuing the cycle of cosmic creation. The study of the Butterfly Nebula provides astronomers with a glimpse into the processes that will shape the death of our own Sun, offering a window into the future of our solar system. By examining the way in which other stars end their lives, scientists can better understand the forces at work in the universe and the ongoing cycle of stellar birth and death. The Butterfly Nebula serves as a reminder that the universe is constantly evolving, with stars being born, living, and dying in an endless cycle that shapes the cosmos. In many ways, the death of a star is a paradoxical event. While it marks the end of a particular star's existence, it also marks the beginning of something new. The material expelled by dying stars enriches the interstellar medium, providing the raw materials for the formation of new stars and planets. This process of stellar recycling ensures that the elements created in the cores of stars are passed on to future generations of stars, planets, and even life. The Butterfly Nebula is just one example of the incredible beauty and complexity that arises from the death of a star. Its stunning structure and vibrant colors are the result of a series of intricate processes that take place over millions of years. By studying nebulae like the Butterfly Nebula, astronomers are able to gain valuable insights into the workings of the universe, uncovering the secrets of stellar evolution and the cosmic cycle of birth and death. As we continue to examine the Butterfly Nebula, it's essential to explore its position in the broader cosmic context. This nebula, officially known as NGC 6302, is just one of many planetary nebulae scattered across the universe, but its intricacies and striking form make it one of the most remarkable. The study of such nebulae is crucial not only for understanding the life cycles of stars but also for uncovering the dynamics of interstellar space, which is often overlooked in studies of more commonly observed phenomena. The Butterfly Nebula is located about 3,800 light-years from Earth in the constellation Scorpius. It belongs to a category of nebulae known as planetary nebulae, which are typically the remnants of stars that were once similar to our Sun. However, this nebula is different from most planetary nebulae in its size, structure, and symmetry. The intense central star, which is a white dwarf, continues to burn brightly at the heart of the nebula, pushing out material that forms the nebula's distinct shape. This central star, having exhausted its hydrogen fuel, is now a remnant of a once massive star, slowly cooling down over the course of billions of years. The light emitted by the gases in the nebula is a byproduct of the intense radiation from this central white dwarf. As the star sheds its outer layers, they become ionized, meaning that the atoms within them lose electrons and become charged. These charged particles emit light as they recombine with electrons or when they are excited by radiation. This phenomenon contributes to the nebula's vibrant colors, which range from reds and greens to blues and purples. The Butterfly Nebula, with its sharply defined lobes, also highlights the fact that the star's mass loss is not a uniform process. The material is not simply ejected in all directions equally. Instead, it's funneled into specific areas, leading to the nebula's distinctive shape. The nebula's structure also invites speculation about the underlying mechanisms at play. Astronomers have posited that the two lobes of the nebula may be the result of a complex interaction between the star's magnetic field and its equatorial regions. These interactions likely lead to the formation of the bipolar shape, with gas being funneled along the star's magnetic axis. Additionally, the rapid rotation of the central star could also contribute to the lobe's formation. When a star is rotating quickly, it generates centrifugal forces that can push material outward along its equator, creating a more pronounced shape. These forces, combined with stellar winds and magnetic fields, create the nebula's stunning symmetry and help us understand the various forces that influence the evolution of stars at the end of their lives. Looking more closely at the nebula's chemical composition reveals yet another layer of its complexity. The Butterfly Nebula, like other planetary nebulae, is rich in a variety of elements that were produced during the star's lifetime. These elements, which include oxygen, nitrogen, carbon, and sulfur, were synthesized through nuclear fusion in the star's core. Over the course of the star's life, these elements were expelled into the surrounding space, where they contributed to the formation of future generations of stars, planets, and even life. This cycle of star birth and death is fundamental to the processes that govern the universe. The material expelled by the star in the final stages of its life is not just a random assortment of elements. Rather, it follows a specific pattern of enrichment. The heaviest elements, such as carbon and oxygen, are created during the star's later stages, as it fuses heavier elements in its core. These elements are then expelled in the stellar winds and over time, become incorporated into the surrounding interstellar medium. The fact that the Butterfly Nebula contains large amounts of these elements provides astronomers with valuable information about the star's internal processes and the nature of stellar evolution. While the nebula's central star is a white dwarf, it is important to understand what that means in the context of stellar evolution. White dwarfs are the remnants of stars that were once similar to the Sun but did not have enough mass to end their lives in supernovae. Instead, these stars shed their outer layers in the form of planetary nebulae, leaving behind a dense, hot core. Over time, the white dwarf will cool and fade, but it will not undergo any further fusion. This marks the end of the star's active life cycle. While white dwarfs do not generate energy through fusion, they still provide valuable insights into the processes that govern the lives of stars, particularly those of lower to intermediate mass. The long-term fate of the Butterfly Nebula is also worth considering. As the white dwarf at its center slowly cools, the nebula itself will begin to dissipate. The gas and dust will eventually spread out into the surrounding interstellar medium, where it may be incorporated into the formation of new stars and planets. This process of recycling is a critical part of the cosmic cycle of star formation and death. Over billions of years, the material from stars that have died, like the one at the heart of the Butterfly Nebula, will form the building blocks for future stars, continuing the never-ending process of creation and destruction that defines the universe. The nebula also sheds light on the ultimate fate of the star's progeny, those that will be born from the material it has left behind. The cycle of life and death in the universe is ongoing, and each star that dies gives rise to the potential for new stars to form. These stars, born from the remnants of older ones, will, in turn, go through their own life cycles, eventually dying in similar fashion. The materials released during the death of stars will continue to enrich the cosmos, making the universe a more complex and dynamic place. What's even more remarkable is the realization that the Butterfly Nebula, like other planetary nebulae, represents a crucial stage in the cosmic process of life and death. It is both a graveyard for stars and a nursery for new stars and planetary systems. By studying such nebulae, astronomers gain invaluable knowledge about the forces at work in the universe and the intricate processes that govern the birth, life, and death of stars. The Butterfly Nebula serves as a cosmic beacon, providing us with a snapshot of the universe's ongoing evolution. For us here on Earth, this process might seem distant and far removed from our everyday lives. But the elements forged in the hearts of stars, elements like carbon, nitrogen, and oxygen, are essential to life as we know it. The very building blocks that make up the Earth and all living organisms were created in the cores of ancient stars. The Butterfly Nebula, like so many other stellar remnants, is a symbol of the interconnectedness of all things in the universe, a testament to the fact that we are all made of stardust. In many ways, the nebula is not just a beautiful cosmic object, it is also a metaphor for the cycles of life and death that define existence itself. Stars are born, live, and die in a constant rhythm, and their deaths are not the end, but rather the beginning of something new. The Butterfly Nebula, with its intricate patterns and vibrant colors, encapsulates this cycle, providing us with a window into the cosmos' grand, ever-evolving dance of life and death. As astronomers continue to study the Butterfly Nebula, they will undoubtedly uncover more secrets about the processes that shape the universe. With advances in technology and observational techniques, we may one day learn even more about the physics behind this nebula's formation, the nature of its central star, and the forces that shape the nebula's stunning structure. But even now, the Butterfly Nebula stands as a powerful reminder of the beauty and complexity of the cosmos, a living testament to the forces that shape stars and the material they leave behind. As we continue our exploration of the Butterfly Nebula, it's essential to dive deeper into the way its unique structure provides insights into stellar evolution. A closer look at the nebula's formation reveals the intricate dance of forces that have worked over millions of years to sculpt its striking shape. The nebula is far more than just a collection of gas and dust, it is a manifestation of the death of a star and the explosive forces that shape the universe. The formation of the Butterfly Nebula is a result of complex physical processes that occur when a star reaches the end of its life cycle. The central star, which is likely an aging, low to medium mass star, reaches a critical point where it no longer has the necessary fuel to sustain nuclear fusion in its core. As the fusion process slows down, the outer layers of the star expand and are ejected into space. This expulsion of material is what eventually forms the nebula. The outward flow of gas and dust creates a spherical shell of material surrounding the dying star, but the intriguing shape of the Butterfly Nebula suggests that something more than just an even flow of material is at play. What sets the Butterfly Nebula apart is its bipolar structure. Instead of a uniform, spherical shape, the nebula exhibits two distinct lobes of gas and dust that appear to stretch out from either side of the central star. This bipolar shape is one of the most defining features of the nebula and offers significant clues about the dynamics of stellar evolution. While most planetary nebulae are roughly round or elliptical, the Butterfly Nebula is an exception. Scientists have speculated that the star's rapid rotation could be responsible for the formation of the nebula's lobes. As the star spins, its equator is subjected to centrifugal forces that push the material outward, creating two polar lobes of gas and dust that extend into space. This process is known as equatorial mass loss, and is an important factor in the nebula's unique appearance. But the forces at work in the Butterfly Nebula don't stop there. Another factor contributing to its structure is the interaction between the star's magnetic field and the surrounding material. It's thought that the central star's magnetic field plays a significant role in channeling the expelled gas along the magnetic poles, further contributing to the nebula's distinctive shape. Magnetic fields can guide the flow of gas in specific directions, effectively funneling material along the star's poles. This magnetic shaping of the gas is what ultimately results in the dramatic bipolar lobes we see today. In addition to these forces, the nebula's central star also experiences extreme temperature fluctuations that contribute to the gas's ionization and the nebula's vivid colors. The central star of the Butterfly Nebula is a white dwarf, which is the remnant of a star that has exhausted its nuclear fuel. White dwarfs are extremely hot, typically reaching temperatures of around 100,000 Kelvin, and their intense radiation is enough to ionize the surrounding gas. This ionization causes the gas to emit light in the form of distinct colors, ranging from green and red to blue and purple, depending on the specific elements present and the temperature of the gas. Oxygen, nitrogen, and hydrogen are common elements in planetary nebulae, and their emission spectra produce the characteristic glow that we see in the Butterfly Nebula. The nebula's brightness and color are a direct result of the interaction between the radiation from the white dwarf and the surrounding gas. As the gas expands outward from the star, it is heated by the radiation, causing the elements within the gas to emit light at specific wavelengths. For example, ionized oxygen produces a greenish hue, while hydrogen emits a reddish glow. The interplay of these elements creates the nebula's stunning, multicolored appearance, making it one of the most beautiful and striking objects in the night sky. Another key feature of the Butterfly Nebula is the presence of high-speed jets of gas and dust. These jets, which extend outward from the central star, are thought to be the result of the star's intense magnetic fields and rapid rotation. The jets are a powerful indication of the energetic processes taking place in the nebula. These high-velocity outflows of material can travel at speeds of up to several hundred kilometers per second, carrying with them the remnants of the star's outer layers. These fast-moving jets of gas contribute to the nebula's dynamic and evolving nature, as the material expelled by the star continues to interact with the surrounding environment. The material expelled from the Butterfly Nebula is also incredibly important for understanding the long-term evolution of the galaxy. This gas and dust, which were once part of the star's outer layers, will eventually become incorporated into the interstellar medium, the vast expanse of gas and dust that exists between the stars. Over time, the gas from the nebula will mix with other material in the galaxy, enriching the interstellar medium with heavy elements like carbon, oxygen, and nitrogen. These elements are the building blocks for the formation of new stars, planets, and even life. In this way, the death of a star like the one at the center of the Butterfly Nebula contributes to the ongoing cycle of star formation and the evolution of the galaxy as a whole. In fact, planetary nebulae like the Butterfly Nebula play a critical role in the life cycle of the universe. As stars die and expel their outer layers, they provide the raw materials necessary for the formation of future generations of stars. This process is fundamental to the ongoing evolution of galaxies, as the interstellar medium is gradually enriched with heavier elements. These elements are essential for the formation of planets, which in turn may host life. In this sense, the Butterfly Nebula is a symbol of the universe's constant transformation, where the death of one star paves the way for the birth of new ones. The nebula also offers important clues about the future of our own Sunday. While the Butterfly Nebula is much more dramatic in appearance, the processes that created it are similar to those that will occur when our Sun reaches the end of its life. As our Sun runs out of fuel, it will expand into a red giant, shedding its outer layers and creating a planetary nebula. The material expelled by the Sun will eventually become part of the interstellar medium, enriching the galaxy with elements that will go on to form new stars and planets. Although our Sun's eventual death is billions of years away, the Butterfly Nebula serves as a preview of what is to come, a reminder that the cycle of life and death in the cosmos is an ongoing, ever-changing process. The study of the Butterfly Nebula is an ongoing endeavor for astronomers, who continue to investigate its structure, composition, and the processes that have shaped it over time. With advanced telescopes and imaging techniques, scientists are able to capture increasingly detailed views of the nebula, unveiling new layers of complexity and revealing the intricate interactions that govern the death of stars. The more we learn about the Butterfly Nebula, the more we come to understand about the fundamental processes that shape the universe, from the birth of stars to their eventual demise. The Butterfly Nebula serves as a powerful reminder of the transient nature of the universe. Stars are born, live, and die in an endless cycle, with each death giving rise to new stars and new possibilities. The nebula is a beautiful and dynamic representation of this process, a cosmic masterpiece that continues to evolve as it disperses its material into the interstellar medium. The intricate patterns of gas and dust, the vivid colors, and the stunning symmetry of the nebula all reflect the cosmic forces at work, shaping the universe in ways we are only beginning to understand. By studying the Butterfly Nebula, we are not just observing a distant object in space. We are gaining insight into the very nature of the universe itself. We are learning about the forces that drive the birth, life, and death of stars, and the processes that shape the cosmos. The nebula is a symbol of the universe's ongoing evolution, a testament to the beauty and complexity of the natural world. As we continue to explore the mysteries of space, the Butterfly Nebula will undoubtedly remain one of the most fascinating and awe-inspiring objects in the cosmos. The Butterfly Nebula also raises fascinating questions about the nature of life and death in the universe, pushing the boundaries of what we know about cosmic phenomena. How do stars transition from their luminous, stable states to the dramatic, violent ends that produce nebulae like this? What mechanisms contribute to the incredibly beautiful and complex patterns that emerge from these dying stars? And perhaps most importantly, what can these answers tell us about our own planet's future, as well as the broader cycles of creation and destruction that govern the universe? To better understand these processes, astronomers use a variety of tools, both ground-based and space-based, to observe nebulae like the Butterfly Nebula. Observatories such as the Hubble Space Telescope have provided us with some of the most detailed images of nebulae, revealing their intricate structure and uncovering the secrets of their formation. The Hubble's sharp, clear images of the Butterfly Nebula have allowed scientists to study the nebula in unprecedented detail, mapping out the shape and distribution of its gas and dust, and helping to piece together the complex story of its creation. The nebula's unique shape, with its distinct wings and central star, has long been the subject of study, and each new observation brings us closer to understanding the forces at play. It is through these observations that scientists have learned more about the central star's role in shaping the nebula. We now know that this star is a white dwarf, a star that has exhausted its nuclear fuel and collapsed in on itself, forming a dense, hot remnant. The intense heat of the white dwarf causes the surrounding material to glow, ionizing the gas and giving rise to the nebula's vibrant colors. In fact, the white dwarf at the center of the Butterfly Nebula is the primary source of energy that sustains the nebula, driving its continued expansion and interaction with the surrounding space. As we look deeper into the nebula, we begin to uncover the subtle details that reveal the complex processes occurring within it. The gas and dust in the nebula are not static. They are constantly moving and interacting with one another. This motion can be seen in the form of swirling clouds and filaments of gas, which twist and turn in response to the forces exerted by the central star's radiation and magnetic fields. These interactions create a dynamic, constantly changing environment, where new patterns emerge and old ones fade away, much like the life cycle of a star itself. The Butterfly Nebula is just one example of the stunning diversity of planetary nebulae that exist in the universe. While each nebula is unique in its shape and structure, they all share a common origin: the death of a star. This fact underscores the interconnectedness of the universe, where the end of one star's life leads to the birth of new stars, planets, and even life itself. The gas and dust expelled by dying stars are the building blocks for future generations of stars, enriching the interstellar medium with elements like carbon, oxygen, and nitrogen, the very elements that make up our own bodies and everything around us. In the grand scale of the cosmos, the Butterfly Nebula is but a fleeting moment in the life of a single star. However, it serves as a powerful reminder of the processes that govern the universe, offering us a glimpse into the future of our own sun and the fate of our solar system. As our sun nears the end of its life, it will eventually shed its outer layers, creating a nebula much like the Butterfly Nebula. This is a distant event, billions of years away, but it is a natural part of the star's life cycle, and it is a process that has played out countless times throughout the history of the universe. In many ways, the Butterfly Nebula is a cosmic masterpiece, a work of art created by the forces of nature. Its stunning, symmetrical shape, vibrant colors, and intricate patterns are a testament to the beauty and complexity of the universe. But beyond its visual appeal, the nebula is also a source of valuable scientific information, offering clues about the life cycles of stars and the evolution of galaxies. Through the study of nebulae like the Butterfly Nebula, we gain a deeper understanding of the universe and our place within it. The Butterfly Nebula also brings into focus the role that technology plays in our understanding of the universe. Without the advancements in telescopic imaging and space-based observatories, we would not have the detailed views of nebulae like this. The Hubble Space Telescope and other observatories have allowed us to study distant objects in unprecedented detail, unveiling the mysteries of space and providing us with a window into the past, present, and future of the cosmos. These tools continue to push the boundaries of our knowledge, allowing us to explore the most distant corners of the universe and uncover the secrets of its formation. As we look to the future, the study of nebulae like the Butterfly Nebula will continue to play a critical role in advancing our understanding of stellar evolution and the life cycle of the universe. New technologies, such as the James Webb Space Telescope, promise to provide even more detailed observations of nebulae, revealing new insights into their structure and behavior. These advancements will help to answer lingering questions about the forces that shape the universe and the processes that govern the birth and death of stars. One of the most exciting aspects of studying nebulae like the Butterfly Nebula is the potential for discovery. Even after decades of research, there is still much we do not know about these cosmic phenomena. Each new observation brings us closer to uncovering the true nature of stellar death, and each discovery adds another piece to the puzzle of the universe's evolution. As our understanding of nebulae and other cosmic objects grows, we gain a deeper appreciation for the complexity and beauty of the cosmos. The Butterfly Nebula is a shining example of the universe's ability to create stunning, awe-inspiring phenomena. It is a testament to the power and mystery of stellar evolution, offering us a glimpse into the incredible processes that shape the stars and the galaxies around us. As we continue to study the nebula and other similar objects, we can look forward to even greater discoveries that will expand our understanding of the universe and our place within it. The Butterfly Nebula is not just a beautiful object in the sky, it is a symbol of the ongoing transformation of the universe, a reminder of the cycles of creation and destruction that govern the cosmos. As we explore its mysteries, we come to understand more about the fundamental forces that shape the universe, and in doing so, we uncover the secrets of the stars, the galaxies, and ultimately, the cosmos itself. The study of the Butterfly Nebula does not just enhance our knowledge of the cosmos, but it also serves as a powerful metaphor for the cycle of life and death that we experience here on Earth. In a way, the nebula is a cosmic mirror, reflecting the fleeting nature of life, yet also highlighting the beauty that can arise from the end of something. As the central star of the Butterfly Nebula nears its death, it begins to shed its outer layers, releasing materials that will eventually form new stars and planets. This cycle of birth and rebirth, death and creation, is a constant theme in the universe, reminding us that endings are often the beginning of something new. Through the study of this nebula, we can better understand not only the fate of stars but also the processes that lead to the creation of new elements and new worlds. The gases and dust released from dying stars are rich with elements like carbon, nitrogen, oxygen, and iron, all of which are essential to life as we know it. These elements are scattered throughout the interstellar medium, enriching the space between stars and eventually contributing to the formation of new stars, planets, and even life itself. This idea of cosmic recycling, where the death of one star leads to the creation of new stars and planets, highlights the interconnectedness of everything in the universe. It is a reminder that everything, from the tiniest atom to the largest galaxy, is part of an ongoing process of change and transformation. And as our own sun reaches the end of its life, it will also contribute to this cycle, shedding its outer layers and enriching the interstellar medium with the elements necessary for the formation of new stars and planets. In this way, the Butterfly Nebula also represents a profound sense of continuity. While the individual stars within it may be dying, their materials will live on, forming the building blocks for the next generation of stars and planets. This cosmic cycle is not just a physical process but a philosophical one as well, reminding us that nothing in the universe truly disappears. It is merely transformed and reconstituted in new forms. As we continue to explore the mysteries of nebulae like the Butterfly Nebula, we are also expanding our understanding of the fundamental forces at work in the universe. The physics that govern the behavior of gas and dust in these nebulae are the same forces that govern the behavior of matter throughout the cosmos. By studying these nebulae, we are uncovering the laws that shape the formation of stars and galaxies, and by extension, the very fabric of the universe itself. One of the most fascinating aspects of the Butterfly Nebula is its incredibly symmetrical shape. Unlike many nebulae, which are irregular and chaotic in appearance, the Butterfly Nebula exhibits a rare symmetry that has intrigued astronomers for years. The nebula's two symmetrical wings, flaring outwards from the central star, are a product of the intense forces at work within the nebula. These forces, driven by the radiation and magnetic fields of the central star, create the intricate patterns of gas and dust that we see today. Scientists believe that this symmetry is a result of the way the central star sheds its outer layers. The star likely experiences strong stellar winds, which push gas and dust outward in all directions. However, the interaction between the star's magnetic fields and the surrounding gas can create a kind of wind tunnel, channeling the gas into the symmetrical, butterfly-like wings that we observe. This fascinating process is still not completely understood, and ongoing research into the dynamics of stellar winds and magnetic fields may eventually reveal more about how such structures form. Another intriguing feature of the Butterfly Nebula is its age. While the nebula may seem like a young and dynamic object, it is actually quite old in cosmic terms. The central star of the Butterfly Nebula has already gone through the red giant phase of its life and is now in the process of shedding its outer layers, transitioning into a white dwarf. This means that the nebula itself is relatively old, and its current state represents the final stages of the star's life cycle. However, the gases and dust expelled by the dying star will continue to evolve and interact with the surrounding space for millions of years to come. The age of the Butterfly Nebula also raises interesting questions about the fate of other stars in our galaxy. As our own sun reaches the end of its life, it will undergo a similar transformation, shedding its outer layers and creating a nebula of its own. This process, however, is still billions of years away, and the sun is currently in the middle of its life cycle. But when the time comes, the sun's death will create a planetary nebula, similar to the Butterfly Nebula, that will serve as a beautiful and dramatic reminder of the life cycle of stars. The Butterfly Nebula also highlights the incredible diversity of nebulae in the universe. While many nebulae are created by the death of stars, each nebula is unique in its shape, size, and structure. Some, like the Butterfly Nebula, have symmetrical shapes, while others are more chaotic and irregular. Some nebulae are vast and diffuse, while others are compact and dense. The variety of nebulae in the universe reflects the complexity of the processes that shape them, and studying these different types of nebulae helps scientists understand the many ways in which stars can evolve and die. In addition to its scientific importance, the Butterfly Nebula also holds a special place in the hearts and minds of astronomers and space enthusiasts alike. Its stunning beauty, with its delicate wings and vibrant colors, makes it one of the most visually captivating objects in the night sky. The nebula's intricate patterns and symmetrical shape evoke a sense of awe and wonder, reminding us of the grandeur and mystery of the universe. For many people, the Butterfly Nebula represents the intersection of science and art. Its colors, shapes, and textures are not just the result of physical processes, but also the product of human curiosity and creativity. Through telescopes and observatories, we have been able to capture the beauty of this cosmic object and share it with the world. The images of the Butterfly Nebula have inspired countless individuals to look up at the stars and wonder about the vast, mysterious universe that surrounds us. As we continue to study the Butterfly Nebula and other similar objects, we are not only learning about the fundamental forces that govern the cosmos, but also gaining a deeper appreciation for the beauty and wonder of the universe. The Butterfly Nebula, with its intricate patterns and stunning colors, is a symbol of the awe-inspiring complexity of the universe and a reminder that even in the final moments of a star's life, there is beauty and wonder to be found. The study of nebulae like the Butterfly Nebula also has profound implications for our understanding of the universe's past and future. By examining the materials and processes that shape these nebulae, scientists can gain insights into the early stages of the universe's formation and the processes that led to the creation of stars, planets, and galaxies. In this way, the Butterfly Nebula is not just a window into the present but also a key to understanding the past and predicting the future of the cosmos. Looking to the future, the study of the Butterfly Nebula and other nebulae will continue to be a major focus of astronomical research. New technologies, such as the James Webb Space Telescope, promise to provide even more detailed observations of these objects, revealing new insights into their structure and behavior. These advancements will help to answer lingering questions about the forces that shape the universe and the processes that govern the birth and death of stars. The Butterfly Nebula is a stunning example of the beauty and complexity of the universe. Its symmetrical shape, vibrant colors, and intricate patterns are a testament to the forces at work in the cosmos, while its creation story offers us valuable insights into the life cycle of stars and the processes that govern the evolution of galaxies. As we continue to study this remarkable nebula, we will undoubtedly uncover more secrets about the nature of the universe and our place within it. Through the Butterfly Nebula, we are reminded that the universe is constantly changing, evolving, and creating, and that even in the death of a star, there is beauty, wonder, and a story waiting to be told. The Butterfly Nebula continues to captivate astronomers and the public alike, not just because of its breathtaking appearance, but because of the wealth of knowledge it holds about the life cycle of stars and the intricate dynamics of the cosmos. It serves as a natural laboratory for exploring complex processes such as stellar winds, magnetic fields, and the interaction of expelled gases with interstellar space. While the mysteries it holds are fascinating, they are also emblematic of the broader mysteries of the universe, encouraging us to push the boundaries of our understanding. One of the most compelling aspects of the Butterfly Nebula is how it invites us to think about time on a cosmic scale. The processes that create and shape a nebula occur over tens of thousands of years, far beyond the scope of a human lifetime. When we observe the Butterfly Nebula today, we are seeing it as it was thousands of years ago due to the time it takes for its light to reach Earth. This temporal disconnection offers a humbling perspective, reminding us that our observations of the cosmos are often glimpses into the distant past. Moreover, the Butterfly Nebula acts as a reminder of how interconnected the universe truly is. The elements expelled during the star's death are the same elements that will one day form new celestial objects. These materials contribute to the ongoing cycle of stellar evolution, linking the fate of one star to the birth of another. It's even possible that some of the materials from the Butterfly Nebula will eventually become part of a future star system with planets, and potentially even life. In addition to its role in cosmic recycling, the Butterfly Nebula also raises fascinating questions about the role of symmetry in the universe. Why do some nebulae, like this one, exhibit such perfect symmetry while others appear chaotic and asymmetrical? Scientists theorize that factors like the rotation of the central star, the strength and configuration of its magnetic fields, and the environment of the surrounding interstellar medium all play a role. However, the exact mechanisms that lead to such striking symmetry remain an area of active research. The colors of the Butterfly Nebula, too, hold a wealth of information. The vibrant hues seen in its images are the result of specific gases interacting with ultraviolet radiation from the central star. Hydrogen, for instance, produces red and pink tones, while oxygen glows in shades of green and blue. These colors are not just aesthetically pleasing, they also serve as a diagnostic tool for astronomers, allowing them to identify the composition and physical conditions within the nebula. By studying the light emitted by the nebula, scientists can determine its temperature, density, and the chemical makeup of its gases. Furthermore, the Butterfly Nebula's unique appearance is influenced by the binary nature of its central star system. The gravitational interaction between the two stars may have contributed to the formation of its symmetrical wings, as their combined forces help to shape the flow of gas and dust. This highlights the critical role that binary systems play in shaping the features of many nebulae. Understanding this dynamic can provide insights into the evolution of other binary systems throughout the galaxy. As we delve deeper into the mysteries of the Butterfly Nebula, we are also learning more about the broader phenomenon of planetary nebulae. These structures, despite their name, have little to do with planets. The term originated in the 18th century, when early astronomers observed them through telescopes and noted their round, planet-like appearance. Today, we know that planetary nebulae represent one of the final stages in the life of a medium-sized star. Such as our Sun. Studying these objects helps us understand what will happen to our solar system billions of years from now when the Sun reaches the end of its life. This research also underscores the importance of interdisciplinary collaboration in astronomy. The study of the Butterfly Nebula brings together experts in spectroscopy, computational modeling, and astrophysics to decode the data collected by telescopes. Advances in imaging technology, such as adaptive optics and space-based observatories, have allowed us to capture the nebula in unprecedented detail, revealing structures and features that were previously invisible. The Butterfly Nebula's story is also a testament to the power of curiosity-driven science. When we study objects like this, we are not just seeking practical applications but pursuing a deeper understanding of the universe for its own sake. This drive to explore, to ask questions, and to seek answers is one of humanity's most defining traits. It is through this exploration that we uncover the profound connections between the cosmos and ourselves. And yet, the Butterfly Nebula is just one of countless nebulae scattered across the universe. Each one tells a unique story about the stars that created it and the environment in which it formed. From the towering pillars of gas in the Eagle Nebula to the chaotic remnants of supernovae like the Crab Nebula, these celestial objects are as varied as they are beautiful. The Butterfly Nebula, with its distinctive symmetry and vivid colors, stands out as a particularly striking example, but it is also a reminder of the vast diversity of forms that nature can take. As we look to the future, new missions and technologies will undoubtedly expand our understanding of the Butterfly Nebula and similar objects. The James Webb Space Telescope, for instance, is poised to revolutionize our ability to observe distant nebulae in unprecedented detail. By studying the infrared light emitted by the nebula, this telescope can peer through the dense clouds of gas and dust to reveal the structures hidden within. This will allow scientists to map the nebula's three-dimensional shape and better understand the forces shaping its evolution. At the same time, ground-based observatories equipped with advanced instruments will continue to provide complementary data, allowing astronomers to study the nebula across a wide range of wavelengths. These efforts will help to answer lingering questions about the physics of stellar death, the role of magnetic fields, and the complex interplay between gas, dust, and radiation. The Butterfly Nebula is more than just a scientific curiosity. It is a source of inspiration. Its intricate beauty and profound story remind us of the incredible processes at work in the universe and our place within it. Whether viewed through the lens of science, or simply appreciated for its aesthetic value, the Butterfly Nebula is a testament to the power of the cosmos to captivate and inspire. As we continue to study and explore, we are reminded that the universe is vast, complex, and filled with wonders waiting to be discovered. The Butterfly Nebula is one of many such wonders, and it invites us to keep looking, keep questioning, and keep marveling at the beauty and mystery of the cosmos. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.